In the heart of this fast paced world where technology and innovation shape our everyday lives, there's one language that stands out as a true game changer, a language that has revolutionized industries, empowered individuals, and sparked the imaginations of millions. That language is Python. Welcome to Python Basics, a comprehensive guide to diving into the world of Python programming. In this video, we will embark on an exciting journey together, exploring the fundamentals of Python and equipping you with the essential skills to begin your coding adventure. But before we dive into the nifty gritty of Python, let's take a moment to discover why this language has become a force to be reckoned with. Allow me to share some captivating facts and statistics that highlight the Python's significance and popularity. Python isn't just a programming language, it's a phenomenon that has swept across the globe. With its rise in popularity, Python has become the driving force behind groundbreaking advancements in artificial intelligence, data analysis, web development, and so much more. According to various programming language indices, Python consistently ranks among the top programming languages worldwide. It has secured its spot among the top 3, surpassing many traditional favorites. The demand for Python skills has skyrocketed with numerous job postings requiring proficiency in Python for roles ranging from software development to data science. One of the key reasons behind Python's immense popularity is its versatility. Python offers a rich ecosystem of libraries and frameworks that cater to diverse needs, from data manipulation with NumPy and Pandas to web development with Django and Flask. Python provides an extensive toolkit to solve a wide range of challenges. But Python's appeal goes beyond its technical merits. It has captured the hearts of developers worldwide due to its simplicity and readability. Python was designed to be easy to understand and write, making it an excellent choice for beginners. Its syntax emphasizes code readability, allowing developers to express their ideas in a clear and concise manner. Python's community is another factor that sets it apart. With a vibrant and supportive community of developers, educators, and enthusiasts, Python fosters collaboration, knowledge sharing, and growth. You will find numerous online resources, tutorials, and forums where Python enthusiasts come together to help one another and push the boundaries of what's possible. Now that we have uncovered the fascinating world of Python, it's time to embark on the next phase of our journey, Python Basics. In the following segment, we'll explore the fundamental concepts, syntax, and practical examples that will form the bedrock of our Python knowledge. From variables and data types to control flow and functions, we will guide you through each step, ensuring you grasp the core principles of Python programming. By the end of this video, you will be equipped with the essential skills to write your first Python program and confidently continue your coding journey. So get ready to unlock the power of Python, the language that's shaping the future and opening doors to endless possibilities. Our adventure begins with an introduction to Python, where we will dive into the history and features that make Python such a powerful and popular language. Next, we'll guide you through the process of installing Python on Windows, ensuring you have a seamless setup to begin your coding journey. With Python up and running on your system, it's time to write your first Python program. We'll walk you through the process, unraveling the basic structure and syntax of a Python program. As we delve deeper, we will explore Python data types, understanding how Python handles different types of data such as numbers, strings, lists, and more. Variables play a crucial role in programming, and in Python, they serve as containers for storing and manipulating data. In our next segment, we will learn about variables in Python, how to assign values, and work with them effectively. Then, we have Python object types and type conversion. That will be our next stop, where we will discover the various built-in object types that is available in Python and how to convert between different types. The next we have is strings that are an essential part of any programming language, and Python offers various tools to work with them. In our segment on strings in Python, we will explore string manipulation, concatenation, and more. Then we have operators that are the building blocks of any programming language, and Python provides a wide range of operators to perform various operations. Join us as we unravel the world of operators in Python. Next, in the world of decision making, if statements in Python come to the rescue, we will guide you through the usage of conditional statements, allowing your programs to make decisions based on certain conditions. Then we have looping that constructs and essential for repetitive tasks. And Python offers the powerful for loop. We'll explore the intricacies of for loops in Python, understanding how to iterate over sequences and perform tasks efficiently. Finally, we'll put our newfound knowledge into practices with Python projects for beginners and get ready to embark on exciting projects such as word count in a textbook. The next would be tracing the movement for a robot. And the next is checking the validity for a password. By the end of this video, you will have gained a solid foundation in Python programming, equipped with the necessary skills to tackle real-world challenges and unleash your creativity. Get ready to unlock the power of Python and embark on an incredible coding journey with Python basics.
In this introduction to Python video, we will learn what is Python, the features of Python, and where Python is used. We will also look at the popular Python frameworks and libraries and get an idea about the best Python IDEs. Then, we will see the top companies using Python programming and get some hands-on experience by learning the basics of Python on a Jupyter notebook. So let's get started with what is Python. Python is a high-level object-oriented programming language developed by Guido van Rossum in 1989 and was first released in 1991. Python is often called a batteries-included language due to its comprehensive standard library. A fun fact about Python is that the name Python was actually taken from the popular BBC comedy show of that time, Monty Python's Flying Circus. Now, let's look at the top features of Python. First, Python has a simple structure and a clearly defined syntax. This allows the learners to pick up the language quickly, so it is easy to learn and use. Python can run on different operating systems such as Windows, Linux, and Mac, making it a portable language. It enables programmers to develop the software for several competing platforms by writing a program only once. Third, Python is freely available at the official website. Since it is open source, this means that source code is also available to the public. Now, Python uses an object-oriented approach that encapsulates code within objects. Python provides a collection of libraries for various tasks such as machine learning, web development, and data analysis. And finally, in Python, you don't need to assign the data type of the variable. When you assign some value to the variable, it automatically allocates the memory to the variable at runtime. Now, with that, let's move on to the uses of Python programming. Python programming language is used to develop desktop applications and build web applications too. It is popularly used in the field of data science, machine learning, and artificial intelligence to analyze data, build predictive models, and make business decisions. Python is also widely used in game development. Now, let's see some of the popular Python frameworks and libraries. Python can be used for web development using frameworks like Django, Flask, Pyramid, and CherryPy. Now, you can build graphical user interfaces using libraries and frameworks such as tkinter or just Kinter. You can also use PyGTK, PyQt, or PyJS or Python JavaScript. Now, Python is also used to perform machine learning tasks using libraries such as TensorFlow, PyTorch, Scikit-learn, Matplotlib, and SciPy. You can also perform mathematical computations using NumPy and Pandas. Now let's look at the best IDEs that you can use to write programs in Python and perform specific tasks. So we have Jupyter Notebook, which is part of the Anaconda distribution that is widely used these days. Even for our demo in this video, we'll be using Jupyter Notebook. I'll show you in a while. Then we have the Visual Code Editor from Microsoft. This is also one of the preferred IDEs by learners and companies. Then we also have the popular text editor called Sublime Text Editor. Then we also have PyCharm, followed by Python IDLE and Spider as our top IDEs. Now let's look at the top companies that are using Python in our day-to-day work. So we have Google, Quora, Facebook, even Netflix, Spotify, and Instagram. Now there are other top product-based, service-based, and startups that also use Python programming.
So let's start. As you all know, Python is an interpreted language. So you need to install a Python interpreter. So for that, we'll go to the browser and search for Python Now we will move to the downloads page and choose the latest version of Python to download, and the latest version is Python 3.9.5. We'll click on the download. Once the installer has downloaded, open it. Now you can see the installation window for Python. You have to double check both the boxes, add Python 3.9 to path and click on install now. As the installation completes, you can see a screen that says the setup was successful. Now click on close. Now to check whether the Python has been installed successfully on the system or not, we will run a command on the command prompt. Let's open the command prompt, click on start and write cmd. Now to check whether the Python is installed or not, we will run the command python ---- version. Python space ---- version and press enter. So here we can see that Python 3.9.5 version is installed in the system. So yeah, Python is working in the system. Now we'll run some commands for Python. So for that, first we will type py and press enter. And now we will write the basic command, that is print bracket hello world semicolon and press enter. As you can see, hello world is printed here. So yeah, Python has started working in our system. Now we will install libraries of Python. We will be using pip to install NumPy, SciPy, Matplotlib and Pandas library. And before installing the libraries, make sure the latest version of pip is installed in your system. So to check that, we will run a command in command prompt. We will open the command prompt and write a command pip space ---- version and press enter. As you can see, the pip version is 21.1.1 and it's being downloaded with the Python 3.9. So it's the latest version we have downloaded. So now we have to keep one thing in mind before installing SciPy, Matplotlib and Pandas library. First, we need to install NumPy library. So for that, we will run a command pip space install NumPy and press enter. Depending on your internet speed, it will get installed. As you can see, the NumPy library has been installed and there's a warning that our pip version is 21.1.1 and we should upgrade it to 21.1.2. That is the latest version available. So we'll upgrade the pip version. For that, we will write a command python space -m space pip space install space -upgrade space pip enter. Okay, so we made a mistake here in the command. So the mistake is we have written only one minus sign before the upgrade. We have to write two minus signs before the upgrade. So we'll write the command again, python space -m space pip space install space --upgrade space pip and then press enter. And now depending on your internet speed, the pip version, the latest pip version will be installed on your system. As you can see, they have uninstalled the pip version 21.1 and they have installed the latest version, that is 21.1.2. We have installed the first library, that is NumPy, and that's the basic requirement for the installation of SciPy library. So now we will install the SciPy library. So for that, we will write the command pip install SciPy. Pip space install space SciPy and press enter. And depending on your internet speed, it will be downloaded. Now you can see that the SciPy library has been installed successfully, and here you can see that the requirement already satisfied NumPy. So we have firstly downloaded the NumPy library so that we can easily run the SciPy library. Now we will download and install pandas library. For that we will write the command pip space install pandas and press enter, and this will also install depending on your internet speed. We can see that the pandas library has been successfully installed. Now we are left with matplotlib library, so now we will install that. For that we will write the command pip space install matplotlib and press enter. As we can see, the matplotlib library has been successfully installed. Now we have installed all the 4 libraries. So if you want to check whether the library is installed on your system or not, you can write a command to check that. First you have to write Python and press enter. First we will check for NumPy library, and for that we will create a array. For that we will write the command import NumPy as np and press enter. If you don't get any error, it means that the library has been installed successfully. So now we will create an array a equal to np dot array one comma 2 comma 4 comma 5 comma 7 comma 9 comma d type equal to, we'll set it for float. Press enter, and we want to print this array. Write print array created comma a and press enter. You can see the output array created 1 to 4 and 5 7 9. So the NumPy library is working fine. So we will check for other libraries. For that we will write import space matplotlib and press enter. If you don't get any error, it means that the library has been installed successfully. So for the rest also we can write the same commands, import pandas and press enter. We do not get any error, so the library has been installed successfully and we are left with SciPy. So we'll write import space SciPy and press enter. So here also we didn't get any error, so the library has also been installed successfully. Now we will see what Anaconda is. Anaconda is a free and open source distribution of Python and R language. Here we have Conda, which is a package manager system similar to pip in Python. So now we will see how to download Anaconda and then we will explore its features. To download Anaconda, first we will open the browser and search for the keyword Anaconda. We have to visit the official website, that is www.anaconda.com. And now we will click on the product section and choose the individual edition, as it is open source edition and it is free of cost. Now we will scroll down. Here is the toolkit for the individual edition and we'll click on the download. On clicking the download, we are directed to the bottom of the web page, and here we can see the different versions available for Windows, that is 32-bit and 64-bit, We will download the 64-bit and it is of size 477 MB, so it will take ample amount of time to download. We will download it. As the download completes, click on the application file. Now click on Next. The license agreement will appear. Now click on I agree. Then you have to select the installation type. If you want to install for a single user, click on Just Me. I'll select for all users and click on Next. I am installing for me, so I will click Next. Then it will ask for installation location. After selecting location, click on the Next. For me, the location is fine, so I will click Next. Then advanced installation options will appear. If you have already installed Python on your system, as we have installed already, so we do not have to click on this section. We will only click on this section and press install. It will take time to install. After the installation is complete, click on Next. Then click on Next and uncheck both these options and click on Finish. As you can see, the installation has been completed. Now we'll go to Start and type Anaconda. We can see that Anaconda prompt and Anaconda Navigator are visible. First we will open Anaconda Navigator. It's initializing and adding features. Here you can see some pre-installed applications and tools that are already installed in the Anaconda. And if you want to install any other tool, you can. Like you can install RStudio, PyCharm Professional, Orange 3, GlueWiz in the Anaconda. And you already have Spider, Qt Console, PowerShell Prompt, Jupyter Notebook, Jupyter Lab, IBM Watson Studio Cloud, Datalore, cmd.exe prompt. So now we will open Anaconda prompt. Now we'll see which version of Conda is installed in the system. For that we'll write a command conda space info and press enter. Here we can see that the Conda version is 4.10.1. Now we will launch Jupyter Notebook. For that we will write the command Jupyter Notebook and press enter. You can see that the Jupyter Notebook has initiated. Now create a folder where you want to store the projects and rename accordingly. So to create folder, we'll create the folder in OneDrive. I will create the folder on desktop. New folder. We will take the untitled folder and rename it. I'll rename it as Python 1. Now minimize the window and open the desktop. You can see that the Python 1 directory is created, and now we will click on the Python 1 folder and create a Python 3 notebook. As we have created a Python 3 file in the Jupyter Notebook, now we can run the Python commands on it. So we will run some commands, and first we will run a basic command that would be print India, and we will run this command. India is printed here. Now we will run some operators, like we will print 7 into 8 and the run. so it's 56, and we'll also run an exponential operator, print 2 exponent 4, and run. So you can see 16, the result comes out. So now to save this file, first we'll rename it demo1, rename, and we'll save it, save and checkpoint. Now you can check in the directory you have created, python1, that it is being saved as demo1.
But before we begin, if you love watching tech videos, subscribe to our channel and hit the bell icon to never miss an update. As you all know, Python is an interpreted language, so we require a Python interpreter to work upon. While installing Python in our system, we also get Python IDE automatically installed. But before writing a program in Python IDE, we will write a program on command prompt. So for that, first we will open command prompt. We'll click on start and write cmd and click enter. Now the command prompt appears. First we will check the Python version, pip space minus minus version, and press enter. You will see the Python version 3.9. Now we will start writing the Python program. For that, first we have to write the command py and press enter. Now we can start writing a program. We will write a basic program on division. For that, we will assign a value 5 to a variable a and value 10 to the variable b, and we will divide b by a and we will print the value of c and press enter. As you can see, we have got an output 2.0. Now we have run a program on command prompt successfully. Now we will write a program in Python IDE. So to write a program in Python IDE, we will see some steps. First we have to open the Python IDE, then click on File menu and choose the new file, and after writing the program we have to save the program with .py extension, and then we can click on the Run menu and then we will see a Run module and we have to click on that. Now we'll see it practically. For that we'll click on Start and search for IDE, and now we'll click on Python IDE. Now we will follow the steps as we have seen now. We will click on File menu and choose New File. A new window will appear. Here we will type the program to get two numbers inserted by user and add them. But before writing this program, let's understand this program. So Python program on adding two numbers. First we have to get an int value inserted in variable a. For that we will write the command a equal to int round brackets input round bracket started. For the message we have to put it in inverted commas and the first number colon round bracket close and another round bracket close. Now we will insert an int value in variable b. For that we will write the command b equal to int round bracket started input round bracket started. For the message we will put the message in inverted commas and the second number colon, and then we will close this message by round bracket and another round bracket closing. Then we will assign a variable c and add the operation a plus b for that. Now we'll print a message that would be addition of two numbers equal to, that would be in inverted commas, comma c, as c variable will store the result of a plus b. All the statements in the program will get executed line by line. Now we will execute this program on Python IDE. So for that we will write a program here that would be a equal to int round bracket start input round bracket inverted commas enter first number inverted commas close round bracket close
b equal to int input round bracket started inverted commas for message, enter second number inverted commas round bracket close. Now we will assign the operation a plus b in variable c. For that we will write c equal to a plus b, and now we will print c. Before executing this program, we will save this program file, save as, we will save it as demo1, and we will write the extension py and press save. As the program is saved, now we will run this program by click on this run menu and then click on run module. You can see the program has been executed. Now we will write the first number, that would be 10, press enter, and second number we will write 6 and press enter. We will get 16 as an output. So we have executed the program on Python IDE. Now we will see some best Python IDEs in the market. For that, the best Python IDEs in the market are Jupyter Notebook, Visual Studio Code, Sublime Text, PyCharm, Python IDE, and Spider Notebook. Among all these IDEs, we have worked with Python IDE. Now we will write a program in Jupyter Notebook. For that, you have to install Jupyter Notebook. I have installed Anaconda distribution and it has Python IDE already installed. If you want to know how to install Anaconda distribution, go and check the video in Python playlist. So let's open Jupyter Notebook. For that, first we will click on Start and write Jupyter Notebook and click on the Jupyter Notebook Anaconda 3, and we'll wait to get it started in a browser. Now we'll select the location where we want to store the program. We will select the location in OneDrive, desktop, and I've created a Python 1 folder there. So here we'll create a new Python 3 notebook. And name it as first Python program. And now here we can start writing a program. Here we will write a program to multiply 3 numbers. So for that we will get all the 3 integers inserted by the users in 3 variables, and then we will operate the operation multiplication. So for that we will write the command a equal to int round bracket started input round bracket, and here we will print the message, enter first number colon and then inverted commas close and the round bracket close. Now we will enter another integer in variable b. For that we will write the command a equal to int round bracket input round bracket started inverted commas, enter second number colon, and then we will close the inverted commas and the round brackets. And now we will get the third integer inputted by the user in variable c. For that we will write the command c equal to int round brackets input round brackets inverted commas, enter third number colon inverted commas close and round bracket close. Now we will assign the operation of multiplication in variable d. That would be by the command d equal to a into b into c. Now we'll print the variable d, and for that we'll also print the message multiplication of 3 numbers and close the inverted commas, and then we will insert a comma and then write the variable d.
as D contains the output of A into B into C. Now we'll click on the run command, and now we'll enter our first number, that would be 5, and press enter. Then the second number 4, then the third number 6, and then press enter. And then we will get the output of multiplication of 3 numbers as 120. Now we have successfully run the program on Jupyter Notebook.
So in Python, every value has a certain data type. The variables in Python hold an object of a particular data type. Since everything is an object in Python, data types are actually classes and variables are instances of these classes. Now there are various data types in Python. First we have the numeric types, which are essentially numbers. So under numeric types we have integers, floating point numbers and complex numbers. Then we have text type data, which are in the form of strings. The third type of data that is available in Python are called as sequence types, which consists of lists, tuples and range. We have already seen about lists and tuples in our previous video. And in Python, we also have dictionary objects as mapping data types. In the previous video, you saw how to map key value pairs using dictionaries. Next, we have set data type. Now sets are unordered collection of unique items. Python also supports Boolean data types, and finally we have binary types of data, which include bytes, byte array and memory view. Now let's head over to the Jupyter Notebook, where we will learn about these data types in detail. So here I am on my Jupyter Notebook, and I have titled my notebook as Data Types in Python. REC is for recording. So let's first start with numeric data types. I'll give a comment using a hashtag. I'll write numeric data type. Okay. Let me define a variable called num, in which I'll store a value of 7. Now let me go ahead and print the data type of my variable num. So for that I'm using my function as type. If I run this using shift plus enter, you can see here it tells me that num variable is holding a value of type integer. Now you can also use a print statement. I can write something like print num, comma, I can give a message as is of type. I'll give another comma, and then I'll use my function type of num. Let's see the output. You can see it here. It first gets the value that is stored in the variable num, so 7 is of type, and then it prints the class is of type class integer. Alright, I've just increased my size of the notebook. Next, let's declare the same variable num, and this time we'll store the value as, let's say, 10.8. Now you can see here there's a point, which means this is a decimal or a floating value. If you can check the type of num, it gives us num is holding a value of type float. Now let's say I'll take a negative number, let's say minus 10.8, and we'll see the type of num. Again, minus 10.8 is also of type float. Now let's say I'll declare a complex variable, let's say 8 plus 6j. Now this is a complex number, which is again of type numeric data type. If I want to check the data type of num, it gives me complex, because 8 plus 6j is of complex data type. Okay, now if you want to extract the real and the imaginary parts of a complex number, you can do it something like this. You need to pass in the variable name followed by a dot, and the attribute name is real to extract the real part of the complex number. If I run this, you can see here it has returned the real part of the complex number, which is 8. Now if you want to print the imaginary part, you can use num.imeg, which is for imaginary. If I run this, there you go. It gives us the imaginary part, which is 6. Okay. Now in Python you can also perform conversion of data types. So you can convert between different data types by using type conversion functions such as int, float, str, etc. So let me define a variable called num, which has a value 7.8. Now what I'm going to do is I'm going to create a variable called b, which is going to store the integer part of num, which means initially I had defined num as 7.8, which is a floating point number. I want to convert this num to integer type now, and let me go ahead and print my b, and I also print the type of num, and I'll then print the type of b. Let's run this and see the result. Okay, so if you see here clearly, when I see print b, it has returned me 7, which is of type integer. So it has truncated the decimal part present in 7.8. Again, if I print type of num, so num is holding 7.8, it is of type float. Now after converting the float value into integer, it has given me int. Okay. Similarly, let's say we have another number minus 90.5, and if I were to check the type, I would write print type of num. Then let's convert this to integer. So I'll write print int of num. Let's see the results. Okay, so initially minus 90.5 is of type float. After we converted our num to integer, it gives us minus 90, so it has truncated the decimal point part. Alright. Now let's say I'll create another variable, let's say c equal to, let's say I'll write float of b. Now if you remember, our b holds a value of 7. If I were to convert b to float again, I can use the float type conversion function, and let's go ahead and print c. If I run this, you can see here previously b was holding an integer of 7. Now it has converted that integer into a float value, so it is 7.0 now. Okay. Now moving ahead, let's see about Boolean data types. So if I have a variable, let's say r equal to, let's say it has a value called true, which is a type of Boolean value, and let me go ahead and print the type of r. It gives me Boolean. Now let's say I'll write num greater than c. Let's go to the top. If you see here, num is holding a value of minus 90.5 and my c is holding a value of 7.0. I'm checking if num is greater than c. If I run this, it gives me false because minus 90.5 is less than 7.0 and not greater than 7.0. Suppose I create a variable boolean or bool, and I'll store that value num greater than c, and let's print the type of boolean. I'll use type of my variable, that is bool. Let's run it. You can see it here. It tells us that this particular operation is now holding a data type of boolean. If you are getting confused, we can change the variable here. Let's say I'll write b underscore bool, and similarly I'll write here b underscore bool. Let's run it. You get the same thing. Alright, now moving ahead, let's explore how string data types work in Python. I'll give a comment as string data types. Let me scroll down. Okay, so string data types or string values in Python are passed within quotations. Suppose I have a string called str1 and it has a value, let's say Python programming. So this is a text value. I have another string, let's say str2, which has a value, let's say Simplilearn. Now let's run this. Okay, now if I were to check the type of str1, it should give me string. So str here is a string. Now you can also perform extraction operations from the string. Suppose you want to extract the value that is present in my first string, that is str1, at index number 5. Let's run it. Okay, there is some error here. Okay, so this should be str1 and not strl. Let's run it again. It returns us n. Now let's count what is present at the 5th index. So from our previous introduction to Python video, you might be aware that in Python the index number starts with 0. So if you count, p is at index 0, y is at index 1, t is at index 2, h is at index 3, o is at index 4, and then n is at index 5. So hence str1 of 5 returns n. Similarly, if you can check for other string, that is string 2, let's say I want to see the value that is present at -4. Let's run it. It gives us e. Now if you use a negative indexing operation, it will start counting from the backward position. So here n is at -1, r is at -2, then you have a at -3, and e is present at -4. So hence str2 of -4 returns e. Cool. Now you can also perform slicing operation. Suppose I write str1. I want everything that is present between the 0th index to the 5th index. I'll run it. It gives me pytho. So if you check in string 1, it will start counting from the 0th index and go up to the 4th index and exclude the 5th index. So in my string 1, if I start counting from the 0th index, so it is 0, 1, 2, 3 and 4. So it will print from P till O, and that's the result. Okay, now you can also use some inbuilt functions with string. Suppose I write str2 dot find. So I want to find the index where my m is in Simplilearn. So I'll write m within quotations and print it. It returns me 2. If you check again, so s is at 0th index, 1 is at the 1st index, and m is present at the 2nd index. Okay. Now moving ahead, let's explore a few sequence data types. So we'll start with list data type. Okay. Now first of all, let me go ahead and declare a variable called split1 equal to, and this will have some text. Let's say this is orange. Then I'm going to create another variable called L1 equal to, I'm going to split my variable or my string, that is split1, using the split function, and I'm going to split using the comma. So you can see here my string has comma. I'm going to separate each of these words with a comma, and let's print L1. If I run this, you can see it here. Initially my split1 was of type string, and now we have converted split1 to a list. You can see this is a list and it is present inside square brackets. To verify, you can use the type function. So I'll write type of split1. It should return string. You can see it here, str. And now if I write type of L1, it gives me a list. Okay. Now let's see a few more examples. I'll create another list called list1, and let's see it has some values. The alphabet A, we have the number 1, which is in terms of string again because I have passed in quotes. Let's say I have India. Let's make it consistent with single quotations, and let me print what is inside list1. If I run it, I get my list. Now you can check the data type. If I write type of list1, it gives me, it is of type list. Now you can also perform certain operations on list. Suppose you want to add a few elements to your original list. For that, I'm going to create another variable called list2, and let's say list2 has some values, let's say b, comma 2. Now if I write list1 plus equal to list2, and let me go ahead and print list1. Let's see the result. There you go. So our initial list had 3 elements, A, 1 and India, and now we have merged or concatenated 2 more elements, B and 2, and hence this becomes our final list. Okay. Now moving ahead, let's see one more sequence data type, that is tuple or tuple. Now list and tuples we have already covered in our previous video on Introduction to Python. If you need to brush up what list and tuples are, you can check the previous video. So I'm going to create a tuple, that is tup1, and I'm going to store some values. Tuple you can create using braces. I have some value, let's say A, B, C, D, and let's say E, or let's just restrict it to D. Now you can check the type of tup1. You can see here tup1 is of type tuple. Now I'll create another tuple, let's say tup2, and it has some values, let's say E, F, and let's say G. Now if I write tup1 plus equal to tup2, and if I print my tup1, I get the result of a merged tuple which has values of both tup1 and tup2. You can see here our original tuple had A, B, C, D, and then we merged the second tuple and it has given us E, F, G as well, and hence this becomes the final tuple. You can also perform some basic operations on tuple. Let's say I'll write tup1 multiplied by 2. You can see the result here. It has printed my original tuple twice. Okay. Now moving ahead, let's see our mapping data type, that is dictionary. Again, dictionary is also covered in our previous introduction to Python video. You can also have a look at that video. Now the way to declare a dictionary is I'll create a variable dict1, and dictionaries are written using curly braces and have key value pairs. So I'll write my first key as 1, and let's say this dictionary is about animals, and I have, let's say, lion as my first animal in the dictionary. Then I'll create my second key. Let's say the second animal I have is tiger, and let's say my third element is a dog. Let me run it and print my dictionary. You can see this, we have the dictionary printed. Now if you want to check the type, you can write type of dict1. It returns us dict, which means dictionary. You can also print the length of dict1, and it gives us 3, which means our dictionary has 3 elements. Okay. Now moving ahead, we'll explore our set data type. Now as we understood that sets are unordered collections of values, and these values are always unique. So I'll write set1, let me give a space, equal to, again sets are written within curly braces. I'll create a set, let's say it has some duplicate entries as well, and I'll print my set1. It returns only the unique values, so it has dropped this 5 which was duplicated. Now you can check the type of set1. It gives us it is of type, or the object is of type set. Now suppose I have another set called set2, which has values, let's say a, comma b, and let's say we have some numbers 3 and 4. I'll tell you the operation that I'm going to do. I'm actually going to do an OR operation. So I'm going to print set1 or set2. So this is an OR operator in Python. Let's print the results. You can see here it has printed all the values that are present inside set1 or set2. So in set1 we have 1, 2, 3, 4 and 5, and in set2 we have a and b. So it has dropped 3 and 4 because these are not unique, and 3 and 4 are also present in set1. Suppose I were to perform an AND operation, I'll write set1 ampersand set2. If I run this, you can see here it has only printed the unique values that are present in both set1 and set2. So 3 and 4 are the unique values, and hence it has printed 3 and 4. Let's say I'll write set1 minus set2. Let's see the results. It gives us only those values that are present in set1 and are not present in set2, which is this. Let's see the result if I write set2 minus set1. So this will return the unique values that are present in set2 and are not present in set1. So a and b are the unique values that are present in set2, hence it has printed as a, comma b. Okay. Now another data type we had discussed was range. So range is basically a function. If I write x equal to range 4 and I'll print x, it gives us from 0 till 4, because in Python the first index starts from 0 and goes till 4, so the range is from 0 to 4. Now you can also print the type of x, it returns us a range. Now we'll see some binary data types. Binary data types are not very often used in Python, but it is better if you know. Binary data types can be written as x equal to b. Let's say I have a string. I'll write within double quotations hello world, and let me go ahead and print my variable x. You see here we have hello world, and now let's print the type of x. You see here this is a binary type which is bytes. I'll show you another operation. Let's say you want to extract a specific value from a particular index from this binary data. So again you can use the indexing operation. Suppose I write print, I want to extract the value present at the 4th index. It gives me 111. Now this is very interesting. Let's deep dive into this. Let's check what is present at the 4th index of my string. So H is present at the 0th index, E is at the 1st index, L is at the 2nd index, the second L is at the 3rd index, and we have O at the 4th index. So when we are trying to print the index position, it is actually returning us the ASCII value of small o. Now here I have a doc open which is from IBM documentation. If you see the ASCII value of small o or lowercase o, you will find that the ASCII value is 111, and hence it has returned us 111. Let's try for another index number. Let's say I want to find the value which is present at index number -2, and if I run it, it gives me 108. So -2 means it will start from the last index. So -1 is D and -2 is L. Let's see what is the ASCII value of L. If you see it here, the ASCII value of L is 108, and hence it has returned us 108. So this is how the binary data types work in Python. Now let's convert some sequence objects to other type of objects. Let's say I have a string called S which has something like Messi is from Argentina. Now you can check the type of S. Fair enough, it tells us that Messi is from Argentina is of type string. Now what I'm going to do is I'll use my list function and pass in my variable that is S, so that it converts S to a list. And let me go ahead and print my L. You can see here my string S has now been converted into a list, and this is the result. See here, these are all list elements present inside square brackets. Now if you want, you can check the type of L. It should return us list, and you can see it here. Now suppose I have another list, let's say L1, which has some numbers, let's say 1, 15, 3, 6, 0, 8, 4 and 3. Let's say we also have 1. Okay, so this is a list. You can check type of L1. Fair enough, it tells us that this is a list. Now I want to convert this list L1 to a set. Now as we know that set only contains unordered unique elements. So if I write S equal to, I'll use the set function and then I'll pass in my list variable that is L1, and let's print S. it only returns me the unique values present in the list. So it has dropped the duplicate elements such as 3 and 1. Now you can check the type of S, it gives us set. Okay, so that brings us to the end of this demo session on data types in Python. Let me go to the top and I'll brief you what we did in this demo. So first we looked at the different numeric data types. So we saw integer data type, then we saw floating data type. We also had complex data types. We saw how to extract a real part and imaginary part from a complex number. Then we used some type conversion functions to convert the numeric data types from one data type to another. So here we converted a floating type data to an integer type data. Similarly, we saw how to use Boolean data types. Then we saw about string data types. We also performed some basic operations of using indexing method to extract different values. We also saw how you can use slicing to extract a range of values from your string. We used the find function to find the index of a particular character in the string. Then we learned the important sequence data types like list. Then we had tuples. And then we learned about mapping data types such as dictionary. We also looked at set data type. Now later on we explored about range data type and we looked at binary data types. We saw how binary data type returns ASCII value of a certain character. Finally, we converted strings to list, and then we saw how to convert list to sets.
If you're an aspiring machine learning engineer looking for online training and certifications from prestigious universities and in collaboration with leading experts, then search no more. Simplilearn's professional certification program in AI and machine learning from Purdue University, that is in collaboration with IBM, should be your right choice. For more details, you can use the link provided in the description box below.
In this video, we will learn about variables in Python. But before I begin, make sure to subscribe to the Simplilearn channel for interesting tech videos. Now let's get started. So in this video, we will learn what is a variable in Python. Then we'll understand what are object references. We'll also see the different rules for Python variables. And finally, we'll understand variables in detail with hands-on demonstration on the Jupyter Notebook. So variables in Python hold an object of a particular data type. Python variables are containers for storing data values. We do not need to declare variables before using them or declare their data type like we do in other programming languages such as Java or C++. Python is not statically typed. A variable is created the moment we assign a value to it. A variable is a name given to a memory location. So here we can see we have a variable called car and it has a value called BMW. Now this value is of type string since it is written within double quotes. Now, variables can have values of multiple data types. Now Python also allows you to assign values to multiple variables in one line. So here you can see I have assigned X, Y, Z to Audi, BMW and Mercedes in one single line. Alright. Now let's look at object references in Python. A Python variable is a symbolic name that is a reference or pointer to an object. Once an object is assigned to a variable, you can refer to the object by that name. So here we are assigning an integer value of 50 to the variable a. So assignment creates an integer object with a value of 50 and assigns the variable a to point to that object, as you can see here. So a is the variable and it is pointing to the object that has 50 value. Now let's see another example. So in this case we have assigned a variable a which has a value of 50 and then we have created another variable called b that has the value stored in a. Now Python does not create another object in this case. It creates a new symbolic name or reference called b which points to the same object that a points to. So here you can see both a and b are pointing to the same object that is 50. Okay, now In this example, Python creates a new integer object with the value of 100 and b becomes a reference to it. We will explore all of these in our demo. Now, there are some rules for Python variables. Let me just read and we will explore all these rules in our demo session. So first, a variable name must start with a letter or the underscore character. A variable name cannot start with a number. A variable name can contain only alphanumeric characters or underscores. So you can see from A to Z, 0 to 9, or just underscore. Variable names are case sensitive. So here you can see I have written date in 3 different types, and these are read as different variables and not the same variable. And then there are several techniques to write multi-word variables. You have the camel case, you have the Pascal case, and we have the snake case. Don't worry about it, we'll explore these in the demo. Now let me take you to my Jupyter notebook where we will understand variables in detail. Okay, so I am on my Jupyter notebook and I have my title as variables in Python. So let's start with my first variable. Let's say I have a variable called a and I'm assigning 50 to it. Now you must be aware 50 is of type integer. So this a variable is now holding an integer value. Now if you want, you can just print a. If I hit shift enter, it will give me the value of 50. Now to check the data type of a, you can use the type function. Now we have covered data types in detail in our previous video. If you want, you can have a look at it. So I will write type of a. If I hit shift enter, it gives me the integer type. Okay. Now let me show you another function called id. If I write id of a, let's run it, it gives me a number. This is a long number. Now the id function in Python returns a unique id for the specified object. So here object is a. So all objects in Python have its own unique id. The id is assigned to the object when it is created. Now what if I assign 100 to a this time, and let's see the id of a. If I run it, you can see here the values are different than the previous one. So every time the id function will return a unique id for the specified object. Alright. Now we learnt in our theory section that you can assign multiple variables in a single line. Now let me show you how to do it. Suppose I'll write x, comma, y, comma, z. So these are the 3 variables and I want to assign 3 values to them. So let's say x will have 50. In y, I want to store, let's say, 168.6, and my z will have a string or a text value, let's say Simplilearn. Alright, let's run it. Okay, now you can print them one by one. You can see here x has 50, y has 168.6, and z has Simplilearn of type text. You can check the data types if you want. Let's say I want to check the data type of y. It gives me a float because 68.6 is a float. You can check the data type of z. It is of type string. Okay. Now you can also perform the same operation of assigning multiple variables in a single line in another way. Let me show you how to do it. Suppose I want to assign the same value to 3 different variables. Let's say I want to assign the value of 10 to x, y, and z. So I'll write x equal to, y equal to, z equal to, I'll write 10. If I run it and let me print them one by one, you can see here x is 10, y is 10, and z is also 10. Now there is another way to do it, that is I'll pass in my variables x, y, z, and then I can write 10, 10, 10. This will return the same result. Okay. Now let's look at the rules for writing variable names. So these rules we had discussed in the PPT section. Now we'll explore them one by one. So the first rule is a variable name must start with a letter or the underscore character. So let me just give a comment first. Rules for variable naming. So the first rule says a variable name must start with a letter or the underscore character. So if I write, let's say, some random variable name ABC equal to 100, this is valid. You can print it. ABC, it gives me 100. Now you can also write the variable name as A followed by any number. It should be integer number. If I write 102 equal to, let's say, this time I'll give a string, let's say India, and let me print it. It works perfectly fine. Now we also said the name must start with an underscore. I can start with an underscore and then write, let's say 123 is equal to 70.5. Now let me print it. Now this works as well. So you can start your variable name with an underscore followed by a letter or numbers. Let me show you another example. This time I follow the underscore with letters. Let's say dog. I'll just give any random dog name. Let's say I have a dog called Puppy, and let's say I'll print it. This also works. Okay. Now you can have multiple underscores in your name as well. Suppose I'll write underscore name underscore age. This is my variable name. I'll write, let's say, Stuart 36, and let me print it. I'll write underscore name underscore age. This is also a valid variable name. So you can have multiple underscores in your variable name. Now the next rule is a variable name cannot start with a number. So if I write, let's say, for name equal to Gilly, and if I try to print it, it will throw an error. So you cannot have a variable name starting with a number. Alright. Now let me just scroll down. The next rule is a variable name can only contain alphanumeric characters and underscores. So if I write @ then let's say age equal to 40. If I run this, it throws me an error because @ is not recognized and it is not a valid variable name. Similarly, let's say I'll write name $age equal to, let's say, 40. Again, this is not recognized. Dollar, you cannot use it in your variable name. The next rule is variable names are case sensitive. So suppose I have a variable called car which is all in lowercase, and my car has a value, let's say BMW. Now if I were to print car, it gives me BMW. Now suppose I have another variable which starts with a capital letter C followed by lowercase ar. If I were to assign CAR to, let's say, Tata, and I print it, it returns me Tata and not BMW. So you should keep in mind that variable names are case sensitive. Now similarly, I can also have a variable in all uppercase. Let's say my car is of Toyota brand. I made a spelling mistake. Okay, now if I print CAR, it gives me Toyota. So these are the different types of using case sensitive variables. Now another important thing to note is in Python, reserved words cannot be used as a variable name. So let me open a new tab, and here you will search for reserve keywords in Python. Let me open this link or any other link for your reference. You see here, these are all your keywords in Python, and these cannot be used as variable names. Let's try using a few of them. Let's say I'll use break. Let's assign a value to variable break equal to, let's say, 60. If I run it, it gives me an error, invalid syntax, break you can't use. Similarly, let's use another keyword. Let's say I'll use for this time. We have a keyword called for, you can see it here. Suppose I write for equal to, I have, let's say, Virat. If I run this, it throws me an error again. Let's try one more keyword. Do we have try as a keyword? Yes, we have. You can see here try is a keyword. If I write try equal to any random value I'll pick, this time I am giving a floating number, let's say 140.5. If I run it, again it throws me a error. But you can use an underscore and then you can give that keyword, let's say try. I'll assign the same value and let's say we'll print it. This will work fine since the variable name is no more a keyword because we have an underscore in the beginning. Okay, now let me show you some basic operations that you can perform on Python variables. Let's say we have a equal to 100 and let's say b equal to 200. You can assign an operation to another variable called result. Let's say I want the operation to be an addition operation, and let's go ahead and print result. You can see it has given us 300 because in result we are storing the addition of a and b. So 100 plus 200 is 300. Now similarly, you can perform many operations, like let's say this time we'll perform a subtraction operation. So this time I'm storing a minus b in result, and let's go ahead and print result. You can see here 100 minus 200 is minus 100. Then you can also have, let's say, result equal to a by b, and let's print it. Fair enough, we have 0.5 because 100 divided by 200 is 0.5. Similarly, you can also have integer division. Suppose I write 100 divided by, say, 40, and I'll print the result. You see here it has given us 2.5, but what if I want to perform an integer division? So I'll add one more forward slash here and let's run it. It gives me only 2, so it has truncated the 0.5. Okay, now moving ahead, let's say I have a variable called country and I have India in it. So country is my variable name and it is pointing to the object that has India as the value. I can print the variable. You see here I have India, and now if you want you can perform some extraction operation. Suppose if I write country within square brackets, if I write 3, it gives me the character that is present at the third index. So I is present at the 0th index, N is at the first index, D is at the second index, and I is at the third index. Let's say I want everything that is present until the third index. It gives me I and D. So this 3 is exclusive. It will only return us the values present at the 0th index, the first index, and the second index. Okay. Now let me show you another interesting example. Suppose I have a list that is called cars, and I have a list of car names. Let's say I have BMW, then I have Ferrari, and let's say I have Toyota. I'll run it and I'll print my list that is cars. You can see here there are 3 car names. And now what if I want to put each of these car names in different variables? So I can write x comma y comma z, and I'll write equal to cars. If I run this, now what it will do is it will assign each of these values to x, y and z respectively. Now if you want to print x, you can see here x has BMW, then y has Ferrari, and z has Toyota. So this is another way to assign values to variables from a list. Okay. Now you can also use variables in the print function or the print statement. Suppose I write x equal to, let's say it has Simplilearn. Now I can print a message, let's say welcome to, I'll give a space, close the quotations, give a plus sign, and I'll give the variable name. If I run it, you can see here the message is printed welcome to and the x which has the value of Simplilearn. So welcome to Simplilearn. Okay. Now another thing to note in Python is that you cannot add an integer and a string. Suppose I have x as the variable and it has a value, let's say 20, and then I have y which has the string Simplilearn. Now string can be put in double quotes or in single quotes. You can use whichever way you want. Suppose I print x plus y. Let's see the result. It gives us an error. So you cannot print or add an integer and a string. So you need to convert one of these values. Now there are several techniques to write multi-words variables. You can use the camel case to write multi-word variables. So here each word except the first starts with a capital letter. So I'll just give a comment here and write camel case, and the way to write is apart from the first word, all the words start with the capital letter. Suppose I write my department equal to marketing. So here the first word my, the M starts with a small letter, while the second word department, the D starts in a capital letter. So this is an example of a camel case. If I want to print it, I can write my department and run it. It gives me marketing. Let's see another example. I have, let's say, car brand. So you see here car brand are 2 words, but the first word starts with a small letter while the second word has an uppercase B. Let's say my car brand is Hyundai. Now you can print it. There you go. Alright. Moving ahead, we also have Pascal case where each word starts with a capital letter. Suppose I have a variable called my name is, let's say, Nathan. Here you can see my and name are 2 different words and both the words start with a capital letter. So this is an example of Pascal case. If I run it, let me just print it first. Okay, you see here I have my name. Similarly, let's say we have another Pascal case multi-word variable which is age now, where age has A caps and now has N caps. So this is also an example of a Pascal case variable. Let's say my age now equal to 30. I'll print age now. It returns me 30. Now one thing to note here is if I write, let's say, age now, if I do this, it gives me an error because your variable names are case sensitive. So we haven't created any variable which has small a and small n in age now. Okay. Now the third way to write a multi-word variable is called as snake case. So if you want, I can give a comment saying snake case. So here each word is separated by an underscore character. So let's say I have a multi-word variable which is city underscore address, and let's say the city is New York. Now if I print it, you have New York. So this is an example of a snake case where each word has a underscore in between. You can have multiple underscore between each word. Suppose I write my current age equal to 35, let's say. So I have my current age. If I run it, okay, there is some mistake here. I have missed an R. You see here it says 35. So this is also an example of a snake case where each word is separated by an underscore. So here we have two underscores. Alright, now let me go to the top and let me brief you what we did. So first we saw an integer value variable. We saw how you can check the data type of the variable using the type function. Then we explored about the id function. We saw how you can pass in variables or multiple variables in a single line. Then we saw how you can assign the same value to 3 variables in one line. Now this is another method to do the same operation. Now then we looked at the different rules for naming variables. Your variables can start only with a letter or an underscore, and that letter can be followed up with numbers as well, and you can have similarly numbers after underscore. You can also have characters after underscore. You can have multiple underscores, but your variable name cannot start with a number, and it cannot have special characters like @ or dollar symbol. These will throw an error. Now you can see your variable names are case sensitive. So here we defined car in 3 different ways, and all the 3 gave us different results. Another important thing we saw was you cannot use keywords, Python keywords, as variable names. We saw break, for, and try. Now we performed some basic mathematical operations. We also saw how you can perform some extraction operation using string values in Python. Then we saw another way to assign the values of a list to different variables. We saw how you can use the variable name in a print statement. Then we saw how you cannot add an integer with a string. We explored the camel case. Then we saw how you can write multi-word variable using Pascal case, and finally we looked at snake case. In this video we will look at Python object types and type conversion. Objects are the most fundamental concept in Python programming. So we are going to learn the built-in objects that Python provides. So now let's see the agenda for today. So we are going to talk about object types in Python. Then we'll see the different type conversion functions that are available in Python. Then we see the different types of type conversion. Alright. Now let's look at the different types of objects in Python. So we have lists, You have tuples, numbers, strings, dictionaries, sets. You even have file objects. Then you can see we also have other core types such as Boolean and none. Then we have program unit types like functions, modules, and classes. Now we will touch upon most of them in the demo section of this tutorial. Then we also have implemented related types. Alright. Now let's see how you can convert one data type to another using type conversion. So Python provides two types of data conversion techniques. One is called the implicit type conversion and the other is called the explicit type conversion. Now in implicit data type conversion, Python can automatically convert one data type to another data type. This process does not need any user involvement. While in external conversions, users convert the data type of an object to required data type by using predefined functions that are listed here. So you can see here we have the different functions. So if you want to convert a specific value to an integer, you can use the int function. We have the float function. Now we have something called as ORD. So the ORD function accepts a string of unit length as an argument and returns the Unicode equivalence of the passed argument. Now we also have hex and oct. So the hex function is used to convert an integer number to its corresponding hexadecimal value. Similarly, the OCT function will convert the corresponding, or let's say will convert an integer number to its corresponding octadecimal value. We have tuple, list, set, dictionary. Str is for string. You can convert a number into a complex number by providing its real and imaginary part. We also have the chr or the character function. Now this is how the basic general syntax looks like. You have the required data type followed by the expression. Okay. So let's head over to our Jupyter notebook and learn the different types of objects as well as look at the type conversions in Python. Okay, so here I am on my Jupyter notebook. Let's first look at number objects. So I'm giving a comment as number objects. Alright, let's say I have a variable called num which is equal to, let's say, 2. Now it's very simple that 2 is an integer. So if you want to check the type, you can just use the type function and it gives us int, which means integer. So here 2 is of a type called number object. Let's say you want to pass a floating value, that's a 2.0. See the results. 2.0 is of type float, and again 2.0 or 2.0 is a number object. Now you can perform various operations on number objects. Suppose you want to add a few numbers. So let's say 321 plus 365, and I'll say add. It gives us the addition of these two numbers, which is 686. Now let's say you want to perform a multiplication operation. Let's say 62 multiplied by 2.5. If I hit shift enter, it gives me the multiplication or the product of these two numbers, that is 55.0. Now Python by default will convert the result to a floating point number if there is one integer and this one float. If you want to return the exponent of a number, let's say I want to know 2 raised to the power 4. So I'm using double asterisk to represent the exponent operator. If I hit shift enter, it gives us 16. So it's basically 2 multiplied 4 times. Now you can also import specific libraries. So let's say I want to import the math library and I want to print the value of pi. So here I have written import math, and then using the module math I am trying to find the value of pi. Let's run it. You see here it says 3.141, so on and so forth. Now you can also import the random module. Let's say I'll write import random, and then let's say I want to print a random number. you can use the random function. Let's run it. You see here, this is a random value that Python has generated. If I run it again, this value changes. Let's run it again. Again, this value changes. Okay. Now we'll shift our focus to understanding string objects in Python. So I'll give a comment string objects. Let's say I have a string A is equal to, and let's say the string has India. Okay. Now if you want, you can print A. It says India. Now suppose I want to extract the value that is present at the 0th index of the string. So the way to do is, I'll pass in my variable name, that is A, and within square brackets I'll give the index value, that is 0. Now one thing to remember, in Python the index value starts with 0 and not 1. So if I do A of 0, it gives me I because I is present at the 0th index. Now let's say I want the last value in this string India, so I need to return A. For that I can use negative indexing by using -1. If I do -1, it gives me A, which is the element present at the last index. Now let's say I'll write A1 and colon. Let's run it. You see the result here, it says NDIA, which means Python has returned everything starting from the first index till the last index. So here colon means you need to return everything that comes after the first index. Now let's say I'll write print A and I'll add, let's say XYZ. Let's run it. You see here, this XYZ has been concatenated with the value that was present inside A, that is India. So the result is India followed by XYZ. Okay. Now if I write A multiplied by 7, it will print India 7 times without a space. You can see it here. Cool. Now let's say you want to replace certain values in the string. You can use the replace function. So if I write a dot replace, let's say I want to replace IA that is present in India with, let's say, XYZ. Let's run it. You see here, IND is fine. After that we have IA, and that IA has been replaced by XYZ. Now let's move on and understand list objects in Python. So I'll write list objects. Okay, so let's go ahead and declare a list L1 within square brackets. Let's say we have values like 101, let's say America, and then let's say we have another floating value, let's say 2.05. This is my list. If you want to print the list, you can use L1 to print it. You see here, this is my list L1. Now if you want to find the length of L1, you can use the len function. If I run it, you get 3, which means there are 3 elements in the list: 101, America, and 2.05. Now if you want to extract certain values from the list, for that you can use the indexing method. Let's say I'll write L1 of 1. That gives me America because at index position 1 we have America. So 101 is at the 0th index, America is at the first index, and 2.05 is at the second index. Next, let's say I write L1 and then I give colon -1. Let's print it. So that gives me 101 and America. So what it does is, this colon -1 will exclude the last index and print the other 2 elements in the list. Okay. Now if you want to append some elements to the list, you can use the append method. So I write L1.append. Within brackets, I'll give my value, let's say USA. Now let's go ahead and print L1. If I run it, you can see the difference. Earlier, my list had 3 elements, 101, America and 2.05. Now we have added the 4th element, that is USA. Cool. Now you can also use the pop function in Python. Let's see what it does. So if I write L1.pop and I'll give, let's say 3. If I run it, it returns me USA because USA is present at the 3rd index of my list. If I write pop 1, it gives me America because America is present at the 1st index. Alright. Now you can also reverse the elements in a list. If I write L1 dot reverse function, if I run this and then I'll print L1, you see the result here. We have 2.05 and 101, which is printed in reverse order. The reason being, we have already popped America and USA out and we are only left with 101 and 205. And if you reverse the current list, it will be printed as follows. So 2.05 comes at the beginning and then we have 101. Let me just rerun my list again to show you the difference. I have run my L1. Let's run this append query. And now let's use the reverse function. There you go. So now our original list has been reversed. So you have USA at the beginning and 101 towards the end. Okay. Now moving ahead, let's see the next type of object in Python, that is dictionaries. Okay. Let's say I'll create a dictionary called dict1, and you might be aware that dictionaries are created using the curly braces. So I'll have my key value pairs. Let's say my key is 1 and the value it holds is, let's say, the names of animals, tiger, comma, we'll have the second key and that second key will have the value, let's say lion, and let's say we have another element with the 3rd key and let's say we have mouse. Okay. Now let's print our dictionary. So this is how my dictionary looks like. Now you can display the keys by using the keys function. So this will return all the keys present in the dictionary. You see here 1, 2 and 3 are my keys. Similarly, you can display the values in the dictionary. You need to change these keys to values. If I run it, you see here tiger, lion and mouse are the 3 values. Now suppose you want to add another element to your dictionary. For that you can write dict1 and give the 4th key equal to the value, let's say cat. Now let's run dict1 and see the difference. There you go. So here we have added another element to the dictionary, which is cat. Now moving ahead, let's explore tuple objects. Okay, so we'll create a tuple called t1 equal to, we'll have the values 1, 2, 3, 4, and let's say you want to print the length of tuple t1. It gives you 4 because we have 4 elements in the tuple t1. Now let's say I'll declare one more tuple called t2, and this time we'll have 2 more elements in the tuple. So I'll write t1 plus followed by the 2 elements that I want, let's say 7, 9, and I'll print t2. If I run it, you can see here we have added 7 and 9 to our original tuple that had 1, 2, 3, 4. Now you can also use the indexing method or the slicing technique to extract values from the tuple. Let's say I write T2 of 3, it will return the third element that is present in tuple T2. So if you see here, my third index has the element 4, hence it has returned 4. Cool. Now moving ahead, let's see how file objects work in Python. Alright. Now using Python you can create files. Let's say I want to create a text file in Python using the Jupyter Notebook. For that I can write f1 equal to, I'll use a function called open, and inside this open function I want to create a text file, and first I'll write something into that file. Let me show you. So this is a folder that I have. The folder name is called object types and it is present in my desktop. So I'll use this location, and here you can see now this folder contains no files as of now, but we are going to create a text file using Python. Let's see how to do it. So here I'll paste my location that I've just copied. Now one thing to note is you need to convert everything to forward slash, or you can use double backslash also. I'll give another forward slash, and let's say I want to create a file in the name of data.txt. So it is going to be a text file. Make sure everything is inside single quotation, and I want to open the file in write mode. So I'll write W here. Let's run it and see the difference. Now if we check our folder, you see here earlier there was no data file. Now we have created a text file in the name of data. You see here there are no information or data inside this text file. Next we are going to add some data to this text file. Let's go back to our Jupyter Notebook. Okay, so we'll write some data to that file. So I'll write f1 dot. After that I'll use the write function, and within single quotations I'll write, let's say, hello Simplilearn, and then I'll give \n to go to the next line. I'll write again f1 dot write, and I'll pass in another message, let's say welcome to Python programming, and we'll give another \, followed by n, and then finally we'll close the file. So I'll write f1 dot close function. Let's run this and we'll see the difference now. If I open this, there you go. We have some data in this text file, that is hello Simplilearn, welcome to Python programming. So this is how file objects work in Python. Alright, now moving ahead, we'll see how sets work in Python. Suppose I create a set called S, and I'll use the set function, and I'll pass in India. So this is a string, and I want to convert this string to a set. Let's say I have another set called S1, and here I have a list of values, let's say U, S, and let's say A. Now if I write S comma S1, so what set does is it will return only the unique values that are present inside each set. So here if you see India, all the elements are unique except I, because I is repeated twice, so it will return I only once in the result. But USA has all the elements present only once, so set will return all the elements. Now what if I'll write, let's say, S ampersand S1. So this will give me only the common element that is present in both the sets. So if you see here in India and in U, S and A, only A is repeating in both the sets, so it gives me A. Suppose I write S, this is the OR operator, and I'll write S1. If I run it, it gives me all the elements that are present inside set S and S1, excluding the repeating elements. So here I is repeating, so it has printed only once. Similarly, you can write S minus S1, so you get only those elements that are present inside set S and are not present in set S1. Now in set S, A is present as well as A is present in set S1, so it has excluded A from the result. Okay. Now we'll see some operations. Let's say I'll write A equal to 7 and B equal to, let's say, 2.0. I'll add A and B and store the result in my variable R, which stands for result. Let's see the output. If I write print R, it gives me 9.0, and if I check type of R, it gives me, there's a spelling mistake, I'll write type of R, it gives me float. So here Python is performing implicit type conversion. So if you add an integer with a floating point number, the result will be a floating point number and not an integer. Now if you say A equal to 7 and let's say B equal to same 2.0, and this time I am explicitly defining my result to be an integer, so I'm using an integer function. So if I write A plus B and if I print R, you see the result, it has given me an integer which is 9. Now to verify, you can also use type of R, it gives me integer, but earlier it returned us float. So this is how implicit and explicit conversion work in Python. Now this example was for numbers. Similarly, you can also perform for strings and for lists, tuples and sets. Now moving ahead, one thing I wanted to tell you was you cannot add a string and an integer. Suppose I'll give a comment, string and integer addition. Suppose I have a variable called A which has a value of 7, so 7 is an integer here. Then I have a variable called B which has a value 2, but this time I'll assign this 2 within quotes, so this becomes of type string. Now if you want, you can check that as well. If I write type of 2, rather type of B, it will give us str, which means string. Now let's say I'll write R, which stands for result, equal to A plus B. Now if I print R, it will give us an error because you cannot add a string with an integer. So it says unsupported operand. The way to fix this is you need to convert this string into an integer explicitly. So this time we'll say equal to 7, B equal to 2, so it is a string. Now I'll write R equal to A plus, I'm going to use the integer function or the int function to convert my B to an integer, and then I'll print R again. Let's do this. There you go. So here we have converted my string value to a numeric value of 2, and this time it works fine. So 7 plus 2 is 9. Okay. Now let's see how you can convert a float value or a floating number into an integer number. Let's say I have a variable called A which has a value, let's say 77.9, and I'm going to create another variable called int underscore A, and I'll pass this to my integer function. So it has int of a. Now let's print int underscore a. So you have 77. So my integer function has truncated the decimal point value that had 0.9. If you want to check the type, you can use the type function. I'll write type of int underscore a. So it gives us integer. Now you can also convert an integer to a floating point value. So if I have a variable called a that has a value of, let's say, 50, and if I write float underscore a equal to, I'll use the float function to convert the variable a to a floating point value, and let's print float underscore a. So it gives us 50.0 instead of 50. You can also check the type of float a. It gives you float. Okay. Now you can also convert an integer to a complex number. Let's say I'll take the same value equal to 50. I'll write comp underscore a, which stands for complex a. I'll use the complex function and pass in my variable that is a. Now let's print comp underscore a. So it gives us 50.0j. So 50 is the real part and 0j is the imaginary part. You can also convert an integer to a string. I'll take the same value, let's say 50. I'll write str underscore a equal to str of a. So I'm using the string function to convert my integer to a string. Let's print str underscore a. It should be an underscore and not an hyphen. Let's run it. There you go. You have 50 within single quotes. You can also check the type of a. str underscore a, it gives you string. Cool. Now we learn how to convert a string to a tuple. So let's say I have a string that has India as its value. If I write ts equal to, I'll use the tuple function and pass in my variable that is s, and then we'll print ts. You can see here Python has converted my string s, which had India, into a tuple of individual elements, and my tuple is present inside brackets. Cool. Now similarly you can convert a string to a list. I'll use the same string s equal to India, and then let's say I want to convert it to a list. I'll use L1 equal to followed by the list function, and inside the list function I'll pass in my variable that is s, and let's print L1 and see the difference. You see here my string has now been converted into a list. You can also check the data type of L1 or the object type of L1. It returns you list. Similarly, you can also check the type of ts. It gives you tuple because we converted that string to a tuple. Now let's explore how you can convert a tuple to a list. Let's say you have a tuple called t and it has a list of names. Let's say John, we have Mary, then we have, let's say, Mark. Now to convert into a list, we'll use the list function again. Let's say L2 equal to list of t, and let's print L2. So this is a list because it is present inside square brackets. You can check the type of t. So t is a tuple, you see here. If I change this to L2, it gives you list. Cool. Now moving to the next section where we'll see how to convert integer to binary. Suppose I have a variable called a equal to 10, and then I have b equal to bin of a. Let's say we have another variable which is c, and here I want to convert my integer into a hexadecimal value or a octadecimal value. For that you can write d equal to, use the OCT function for octadecimal value. Okay, now we are going to print them one by one. So I'll write print of b, print of c, and then we'll print what is there inside d. We'll run it and you can see the results here. So binary of 10 you see here, hexadecimal of 10 you see the value here, this is an hexadecimal value. Then we have the octadecimal value of a. Okay, now moving to the final section of this demo. Now you can convert a number to its corresponding ASCII character. Let me show you how to do it. Suppose I have n1 equal to 76. Now if I write chr of n1 and run it, it gives me L. Now let's see our ASCII table. So this is my ASCII table, and for 76 you can see here the character is L. So this chr of n1 will return the corresponding ASCII character for that particular number. So here 76 belongs to L. Let's say we have another number n2 equal to, let's say 100. Now if I write chr of n2 and run it, it gives me lowercase d. We'll see the table again, and if you see for 100 we have lowercase d. Now here you have a list of characters. These are special characters. You have uppercase characters, you have at the rate, you have numbers. Each of them have their own ASCII values. Cool. Now you can convert string character into Unicode values. Now let me tell you what Unicode value is. So computers on a basic level deal with numbers. So letters that appear on computers are stored by computers as a list of numbers. So the Unicode standard provides a unique number for every character and supports multiple languages and all special characters. So let's say I have a string S which has the value of capital A or uppercase A. If I write R, which stands for result, equal to ORD, so this is the function which converts a string to a Unicode value. I'll write ORD of S and will print R. If I run it, it gives me 65. So 65 is the Unicode value of A. You can also have digits. Let's say I have 7. I'll run it. So 55 is the Unicode value of the string 7. Let's try for any other letter. Let's say V and run it. You have 86. Okay. So that brings us to the end of this demo session.
If you're an aspiring machine learning engineer looking for online training and certifications from prestigious universities and in collaboration with leading experts, then search no more. Simplilearn's professional certification program in AI and machine learning from Purdue University, that is in collaboration with IBM, should be your right choice. For more details, you can use the link provided in the description box below.
Let's have a look at the agenda for today. So we'll understand what is a string in Python and how to create strings in Python. Then we look at the different string methods and how to perform string indexing, and all these we'll see with the help of hands-on demonstrations on the Jupyter Notebook. So let's understand what is a string. So a string in Python is an object that represents a sequence of characters. In Python we have str as the data type of string. Now you can create strings using single quotes or double quotes. So here is an example where we have used a single quote to write a string. So our string is Hello India, which is inside a single quote. Below, if you see, we have the same string written within double quotes. So these are the two methods in which you can create strings in Python. Now you can also use triple quotes, which are generally for multi-line strings or doc strings. So here is an example. We have a string called str3, and the content it has is human psychology is an interesting subject. Now if you print the string, it will be printed in 2 lines and not in a single line. Now we'll be exploring much more in detail in our demo session, so please wait for a while. Next, we have string indexing. So if you want to extract a few characters from your string, you can use the indexing method. So in Python, a string starts with the index number 0. So here we have a string which is healthy, and the first element is present at the 0th index. So at the bottom you see the forward index, on the top we have the reverse index or the negative indexes. So in Python, as I said, the first index is at the 0th position, so H is at 0, E is at the first index, A is at the second index, so on and so forth. Now similarly, if you look at negative indexing, it starts with -1 in reverse order. So we have -1 for Y, -2 for H, -3 for T, and so on and so forth. Now let's head over to our Jupyter notebook where we'll learn about strings in Python in detail. Okay, so I'm on my Jupyter notebook. First, I'll create a new notebook. I'll click on New and then select Python 3. Okay, so here let me rename my notebook as Strings in Python Demo. I'll click on Rename. Okay, now let's start with our first example. I'll create a variable called str1 that will have a string. You can see here I am using single quotes now. I'll write hi Sam. So here str1 is holding a string called hi Sam, and let's go ahead and print the string str1. I'll hit shift enter to run it. You see here I have my string printed hi Sam. Now if you want to check the data type that str1 holds, you can use the type function, and inside the type function I'll pass in my variable str1. If I run it, you see here it gives us str, which means it is of type string. Now let's create another string str2 using double quotes this time. So I'll write, let's say, hello Angela. I can give exclamation mark. Okay, now let's just print the second string. You see here this is my second string, which is hello Angela. If you want, you can also use the print function here and run it. You get hello Angela. Now let's write a multi-line string using triple quotes. So I'll write str3 equal to, I'll use triple quotes, and then I'll say hi everyone. Go to the next line. I'll write today we will learn about. I'll go to the next line and I'll write strings in Python. Then I'll again give triple quotes to close my string, and let's just print this str3. If I run it, you can see it here. I have now written a multi-line string. Hi everyone, today we will learn about strings in Python. Let me just add a S. There you go. Okay. Now coming to the next topic, we'll learn about indexing. Alright. Let me declare a string str1 which has value as Simplilearn. Now to use indexing and extract certain items in a string or values in a string, you can use square brackets, and inside the square brackets you can give the index position. For example, if I write str1 and in the square bracket I'll give, let's say, I want to find the element or the value present at the 0th index. Let's run it. It gives me S, because as we learnt in the slides, the first index in a string starts with the 0th number. So I have S in my 0th index, so hence it has printed S. Let's explore a few more. If I write str1 of, let's say I want to know what is present at the 3rd index. If I run it, it gives me P. You can check now. So S is at the 0th index, I is at the first index, M is at the second index, and P is at the third index. Let's say I'll write str1 of, let's say, 12. We can see the difference now. It gives us an error. It says string index out of range. The reason being, Simplilearn does not have any value at the 12th index. So it's printing an error saying string index out of range. Now let's change this to 6 and see what we have. At the 6th index we have L. If you count here, S is at the 0th index, I is at the first index, M is at the second index, P is at the third index. The first L is at the 4th index, again I is at the 5th index, and then we have the second L at the 6th index. So we have L printed here. Now let's see how to use the slicing operator using colon. I'll write slicing operator. Okay. I'll use the same string str1. Let me print it once again. We have Simplilearn. Suppose I write str1 within brackets. I'll use the slicing technique now. I want everything starting from the 0th index. I get Simplilearn. So here I am printing everything that starts with the 0th index. Next, let's see what we have if I print my string str1 and write 1:6. I'll run it. It gives me IMPLI. So if you notice here, I want to extract whatever is present from the first index till the 6th index, but excluding the 6th index. So in Python, the indexing method or the slicing method will exclude the last index. So here, if you see, I is at the first index, M is at the second index, P is at the third index, L is at the fourth index, and then we have I at the 5th index, and we have excluded the 6th index, that is the second L. So hence it has returned us IMPLI. Now similarly, let's say we'll see another example. I'll write str1. This time I'll use colon 6. If I run it, you get simply. So it has printed everything starting from the 0th index till the 6th index, but excluding the 6th index. So you have all these values from 0th index till the 5th index. Okay. Now you can also reverse a string. For that you can use negative slicing using 2 colons. If I write print str1 and within square brackets I'll give colon colon -1. Let's run and see the result. There you go. If you see this, it has printed my original string, which is Simplilearn, in reverse order now. So this is a very simple method. If someone asks you to reverse a string or print something in reverse order, you can use the negative slicing method. Now let's explore a few more examples. If I write str1 and within brackets I'll give -1 and run it, it returns me n, because in my original string, if I go on the top, I have n at the last index, which is here -1. Similarly, let's see what we have at -3. We have a here. If I go to the top, you see here n is at -1, r is at -2, and a is at -3, and hence it has given us a. Now let's say I'll write str1. I want to print -2 colon, and let's see the result. It has given us r and n. So here we are printing only the last 2 elements in the string, hence we have used -2. Okay. Now Python does not allow you to reassign values in a declared string. Let me show you what I mean. I'll give a comment here. Reassign strings. Suppose I have the same string str1, which is Simplilearn. say I write str and I want to replace the value present at the third index with, let's say, O. And if I were to print str1 now, Python will throw an error saying str object does not support item assignment. So it is immutable like tuples where you cannot reassign any values. You can also delete a string. Say I have another string called str2 which has a value of, let's say, Python programming. You can use the del keyword and write str2, and now let's print str2. You will see that it says name str2 is not defined because we have already deleted str2 in the above step. Okay. Now let's go ahead and see some of the important string operations. Okay. Say I have str1 which has Python. Now one thing to note, I am using either single quote or double quote. You can use whatever you want. Let's say I have another string which has programming. So these are my two strings. Let's perform a few operations on these strings. Say I write str1 multiplied by 3 and I'll run it. You can see here it has printed Python thrice because I have said str1 multiplied by 3. So in str1 we have Python, and multiplying 3 returns Python 3 times. Now let's say I'll write str1 plus str1. It has merged Python twice, so I have Python and Python repeated. Let's say I write str1 plus str2. We'll see the result. It gives us Python programming. So basically, if you use the plus operator with two strings, Python will perform a concatenation operation, which means it will merge both the strings. Now if you want to find if a specific character is present in a string or not, you can use the in operator for this. Let's say I'll print whether W is present in str1. If I run it, it gives us false because in str1 we have Python, and if you see here we don't have the letter W in Python, and hence it has given us false. Now let me copy this. I'll paste it here. Let's try whether O is there in string1 or not. It gives us true because we have an O here. You can see here we have an O. Similarly, let's say I want to find whether LA is there in string 2 or not. If I run it, it gives us false because in string 2 we have programming and we don't have any LA present in programming. Let's say we'll see whether RO is present in string 2 or not. This time it returns us true because if you see here we have RO in programming, and hence it has given us true. Now you can also print a raw string using the R alphabet. So the way to write is I'll write R, give a single quote. Let's say I'll give a location C drive 2// and let's say I'll write Python 3.7 and run it. It gives me a raw string. Now let's see some formatting methods. I'll write a comment saying format methods. Okay. I'll write a print statement. I'll give double quotes, and here let's see the first example where I'm using curly braces. I'll write and I'll give another curly braces. You'll get to know what I'm doing once I finish this. Let's say I have a message, both are best friends. Then I'm going to use my format method, and inside this I'll pass in my two values for these braces. So these curly braces will be replaced by the words that I pass in, or the values that I pass in within the format method. So here I'll write, let's say, James, and my second person would be Brad. Now let me run it. You see here what Python does is it replaces the curly braces with the names that I have passed within the format method. So it takes the first argument for the first curly brace and the second argument for the second curly brace. So my statement becomes James and Brad both are best friends. Now let me just copy this. I'll show you another example. This time I'll give 1 and 0 inside the curly braces. Now if I run this, there you go. So here James is at the 0th index. So this is basically a list where James is at the 0th index and Brad is at the first index. So if I write 1 and 0, it will take Brad here, and then for 0 it will take James. So now my message becomes Brad and James both are best friends. Now let's try out another example. I'll paste it here. I'll use two variables, let's say A and B, and inside my format method I'll write A equal to James and I'll assign B as Brad. Let's run it. There you go. We have our message printed. James and Brad both are best friends. So here A refers to James and B refers to Brad. Cool. Let's explore another example. I have a variable called name, and that has a value Angela, and then I have another variable, let's say salary of $100,000. I'll use a print statement. I'll print a message. Her name is, I'll use %s for string, give a \n for next line, and I'll write her salary is, then I'll write %d, this is for numbers, and then I'll give another percentage, and let's say I'll write my two variables name and salary. Let's see what we have in the result. I need to close my double quotes here. I'll exclude it from here. Let's run it. There you go. So I have my message here. Her name is Angela. Her salary is $100,000. I'll just delete the space here. We'll run it again. Okay. Now this %s refers to the name, and we have declared her name is Angela. So my first statement or the message becomes her name is Angela, and the next message is her salary is %d. So %d here refers to the salary where we have 100,000. So the next message is her salary is 100,000. So these are the very basic and important print methods or formats that you can use while working with strings. Now we'll explore a few functions that are readily available in Python to operate with strings. I'll take my same string str1 as Simplilearn. and then I'll create another variable called str2. I'll write str1 dot. I'm going to use the capitalize method. Okay, let me make one correction. I'm going to write everything in lowercase so that we can see the difference, how we can capitalize the string. So I'll write my print statement, print old value. This is going to my message. I'll give a colon followed by my double quotes, and I'll pass in my variable str1. Okay, now I'll copy this. In the next line we have a new value as str2. Let's run it and see the difference. There you go. So here my old value has Simplilearn in all lowercase, but when I used the capitalize method, so Python has converted my first letter in Simplilearn to uppercase or capital keys. Cool. Now let me copy this. I'm going to use the same example for the next three methods. Let me show you how the case fold method works. This time I'm going to pass my input string in all uppercase. I'll write Simplilearn in uppercase, and instead of capitalize I'll write case fold. Let's run it and see the difference. There you go. Initially we had Simplilearn in uppercase, and now we have converted into case fold, so all the letters are in lowercase. Now moving ahead, you can also use the upper method to convert a string into uppercase. Let's say I have a string where few of the letters are in uppercase and few of the letters are in lowercase. This time I'm going to convert everything into uppercase, so I'll use the upper function instead of case fold. Let's run and see the result. There you go. So this time Python has converted my original string into uppercase. And likewise you can also use the lowercase. Instead of upper, if I write lower, you see here everything has been converted to lowercase. Cool. Okay, now I'll show you how the title method works. So in title method, all the words, basically the first letter of all the words will be in uppercase. So suppose I have a string which is Simplilearn company. So I'll write, let's say this is my string, and I'll convert my str1 to title case. Let me run it. So this is the difference you can see. The first letter of the first word is uppercase. Again, the first letter of the second word is also in uppercase. So this is how the title case works. Now you can also count the occurrences of a particular element in a string. Suppose I have string 1 that has Python programming. In str2 I'll write str1 dot and use the count function to count how many times, let's say n, the letter n is present. Then I'll print saying occurrences, give a colon here, and then I'll pass in my variable, that is str2. So this will count the number of times n is present in my original string. So if you see here in Python programming we have n present twice. Similarly, let's check for G. The letter G is also present twice. Let's see for Y. Now Y is present only once, which you can see here. Okay. Next, let's see how the replace function works in Python. I'm giving a comment as replace. So let's say I have a string str1 which has Hamburg is located in France. So Hamburg is a city which is actually located in Germany and not in France. So using the replace method, we are going to replace France with Germany. So what I'll do is I'll create another string str2 equal to, I'll write str1 dot, and then I'll use the replace function and I'll say replace my string France with country Germany, and then we'll print str2 and see the result. There you go. So we have changed Hamburg is located in France to Hamburg is located in Germany. Now coming to the final method that we are going to explore in this Python strings demo, which is using the split function. Okay, so you can split the values or each word in a string as separate words and store it in the form of a list. So I write str1, I'll just copy this, I'll paste it here, and I'll change France to Germany because Hamburg is actually present in Germany and not in France. And then I'll create another variable called str2. I'll write str1 dot and then use the split function. Now let me print both the strings. First I'll print str1 and then I'll print str2. If I run it, you see my original string was Hamburg is located in Germany, and then using the split function we have segregated or divided each of the words present in the original string into separate words, and this time it is present in the form of a list. Like any other programming language, Python also supports various types of operators, so we will understand each of them with the help of examples. Let's see what operators are in Python. Now operators are generally used to perform operations on values and variables in Python. These are standard symbols used for logical and arithmetic operations. The value that the operator operates on is called the operand. So here on your screens you can see the different types of operators available in Python. First we have arithmetic operators. So arithmetic operators are used to perform mathematical operations. It returns either true or false according to the condition. So these are the comparison operators. You have less than, greater than, less than equal to, greater than equal to. We have not equal to, and we have equal to equal to. Third, we have assignment operators. So assignment operators are used in Python to assign values to variables. So these are the assignment operators. You have equal to, you have plus equal to. So for example, you have a variable called x, and if you say x plus equal to 7, this means it is x equal to x plus 7. Similarly, if you say x minus equal to 7, this means x equal to x minus 7. And similarly, you can see the other assignment operators here. Next up we have the logical operators. So logical operators are used in the expression evaluation to make a decision. If both the expressions are true, then the condition will be true for an AND operator. For an OR operator, if one of the expressions is true, then the OR condition will be true. Now for NOT, if an expression A is true, then NOT A will be false. We also have bitwise operators. So bitwise operators act on operands as if they were strings of binary digits. It acts on bits and performs bit by bit operation. So hence it is called bitwise operator. So here each value is evaluated as zeros and ones. Then we have identity operators. So identity operators are used to check if two values are located on the same part of the memory. Two variables that are equal does not imply that they are identical. We'll understand each of these operators in the demo session on the Jupyter Notebook. And finally we have membership operators. So membership operators are used to test whether a value or variable is in a sequence. So you have is and is not as identity operators. In membership operators we have in and not in. Now let's head over to our Jupyter Notebook and we'll see and explore all these operators one by one. So I am on my Jupyter notebook, operators in Python. So let's first start with arithmetic operators. I'll just give a comment here saying arithmetic operators. Okay. First up, we'll see the addition operator. For that, let me assign two variables. So I have assigned a variable x to a value 10, and let's say we have the second variable y equal to 4. Now if I say print x plus y, it will perform an arithmetic operation, that is addition, and will sum the result of x and y and gives me 14, because 10 plus 4 is 14. Then let's say I'll write print x minus y, that gives me 6 because 10 minus 4 is 6. Similarly, you can have multiplication as well. So I'll write x asterisk y, that gives me 40 because 10 multiplied by 4 is 40. Similarly, let's say x divided by y. It gives me 2.5, which is basically the quotient of these two operands. Alright. Now if you were to find the remainder, you can use the modulus operator. So I'll write x modulo y, it gives me 2. So you divide 10 by 4, the remainder is 2. Now you can use the double asterisk operator, which is basically known as power. So the left operand is raised to the power of right. I'll write print x, give 2 asterisks, and then say y, it gives me 10,000. So what basically Python does is it will raise 10 to the power of 4. So 10 is multiplied 4 times and the result is 10,000. You can also try out another example. Let's say 2 raised to the power of 4. This gives me 16. If I say 2 raised to the power of 3, that is 2 cube, and the result is 8. You can also perform floor division. So floor division results into whole number adjusted to the left in the number line. So if I write print x, and floor division is given by 2 forward slash, then I'll write y, that gives me 2. So it returns a whole number. A generic division gives me 2.5, that has the floating point value, but a floor division will give me a whole number adjusted to the left on the number line. Alright, so these are some of the basic arithmetic operators that are very popular in Python. Next, we'll move on to assignment operators. I'll give a comment as assignment operators. Okay. Let's assign a value x equal to 7. So here we are assigning the value of 7 to x, and your equal to is an example of assignment operator. Now if I print x, it will give me 7. Now let's say I'll again write x equal to 7, and in the next line I'll write x plus equal to 3, and will print x. So what Python does is it adds 3 to my original value that x holds, that is 7. So here x plus equal to 3 means x equal to x plus 3. So x equal to x plus 3 can be written as x plus equal to 3. Similarly, you can also write x minus equal to something. Say x equal to 7, and then I write x minus equal to 3. Then we'll print x. This gives me 4 because we are subtracting the original value of x by 3. So here x minus equal to 3 means x equal to x minus 3. Okay. Similarly, let's say I'll write x asterisk equal to 3. If I run it and print the value of x, it gives me 12 because our previous x value was 4 and now we have multiplied x by 3. So x value now becomes 12. Let's say I'll write x divided by 3 and I'll print x. It gives me 4.0. This is a floating point number. So we are dividing 12 by 3 and the result is 4.0. Cool. If you want, you can also perform an exponent operation or a power operation. So let's say I have x equal to 7 and then I write x double asterisk equal to say 2 and then we'll print x. Okay, there is an error here. Let's debug the error. I have put a space here. Let's delete that space. You have to keep this in mind. Now let's run it. There you go. So 7 raised to the power of 2, which is basically 7 square, is 49. You can change the values and run other examples. Let's say 10 raised to the power of 3. We have 1000 as the result. Okay. Now moving ahead. Now we'll understand about comparison operators. So I'll give a comment as comparison operators. Okay. Let's say I have x equal to 7 and then I have y equal to 3. If I print x equal to y, it will give me false. The reason being the value that x holds is not equal to the value present in y. These are two different values that x and y hold. So x is not equal to y, and if we print x equal to y, it will give us false. Now I'll just copy this code. I'll print it here and instead of equal to I'll give not equal to. So not equal to is represented by an exclamation mark followed by an equal to. If I write x not equal to y, this gives us true because x and y are two different values and they are not equal. I'll print my code again and this time let's say I'll write x greater than y. It gives us true because 7 is greater than 3. If I write x less than y and hit shift enter, that gives me false because 7 is not less than 3. I'll print the code again. This time we'll see if x is greater than equal to 3. If I run it, it is true because 7 is greater than equal to 3. And now let's check for less than equal to. This is false because 7 is not less than equal to 3. Okay, so these are some of the basic comparison operators that are available in Python. Now moving ahead, we'll see how logical operators work in Python. Okay. First, we'll look at the AND operator in Python. Suppose I have a value of 7 stored in x and then I have a value of 12 stored in y. If I write print x greater than 2 and y less than 10, let's run it and see the result. It gives us false. Now AND logical operators will return true if both the conditions are true, and it will return false even if one of the condition is false. So here x is greater than 2, which means 7 is greater than 2 is true, but y less than 10, which is 12 less than 10, is false, and hence our entire expression becomes false. Next, let's say I have x equal to 5, and then I'll print x greater than 3 or x less than 10. If I run this, it returns us true. The reason being x greater than 3 is true, which means 5 is greater than 3, that is true. But 5 is not less than 10. But since one of the conditions is true, so the OR operation in Python returns us true. Now let's see another example. I'll write x equal to 5 and y equal to 10. I'll print x greater than 10 or y less than 20. If I run this, it returns true. So let's see our expression. X greater than 10, that is 5 greater than 10, is false, but y less than 20, so 10 is less than 20 is true. So our OR operation will give us true since one of the condition is true. Now moving to the next logical operator, we have NOT. I'll give an comment here as OR, and now we'll see NOT. Let's say I have x equal to 5, and then I'll print x greater than 3 and x less than 10. This should ideally give us true. The reason being x is greater than 3 and x is less than 10. Let's run and verify. Okay, so this is true. Now let me copy this and I'll paste it in the next cell. Now I'll replace my above print statement with a NOT operator, and we'll close our print function with another bracket. Now let's run it. So this will give us false because my expression evaluates to true, but not true is false. Okay, now moving ahead, let's discuss identity operators in Python. Alright, so we'll start by assigning a value of, let's say, 505 to x, and then in y I'll have 500 plus 5, so which is also 505. So x and y hold the same value of 505. Now I'll print x comma y. So you can see here both the values are same, 505 for x and y. Now I'll use the logical operator, that is double equal to or equal to. I'll write x equal to y. This will give us true because x and y hold the same value of 505. But let's check with the identity operator. So I'll write x is y. If I run this, it gives me false. The reason being x and y both refer to objects whose value is 505. They are equal, but they are not referencing to the same object. Now this you can verify using the id function in Python. If I write id of x, this will give me the memory location that x has. You can see this is the memory location of x. Now if I write id of y, there you go. So this is a separate memory location in which y is holding the value of 505, and hence x is y is different, and hence it is false. Now suppose I write x equal to 100 and I have y equal to 200. If I write x is not y, this gives us true. The reason being x and y both are holding different values, So X is not Y is true. Let's see another example. This time we'll define two lists. So I have a list called A that has value, let's say 5, 6, 3, 7, 1, let's say 9. And then I'll have another list that will also have the same elements. I'll copy this and I'll paste it here. Okay, if I write C equal to A and then we'll print A is C. If I run this, it gives us true because we are assigning the variable A to C, and hence the memory locations are the same for both, and hence A is C gives us true. What if I write A is B? Now this gives us false. So here A and B are both less. They are equal but not identical. It is because the interpreter in Python allocates them separately in memory although they are equal. Okay, now let's talk about membership operators in Python. I'll give a comment as membership operators. Okay, let's say I have a list A that has the above values 5, 6, 3, 7, 1 and 9. I'll copy this and I'll paste it here. Okay, I have another list B that has different types of elements. We have 4, next element is Python, then we have 2, 7, let's say Simplilearn, and then I have 9. I'll run this first. So I have my two lists A and B. I have printed them. Let's explore how the membership operator works. So we saw in the slides in and not in are two membership operators. If I write 5 in A and run it, it returns me true because you see here 5 is present in A and hence 5 in A will return true. What if I write 55 in A? This gives us false because you see here in the list A we don't have an item 55 in A. So it gives us false. What if I write 4 in B? This gives me true. You see here in B we have the element 4, so 4 in B is true. One thing I wanted to show you is what if I write Python in B? You see here it gives us false. Though we have Python in our list B, but the Python I'm trying to check is not present in B. The reason being here Python is written in lowercase, but what I am checking Python P is in uppercase, so it is case sensitive and hence this gives me false. Let's say I'll declare a dictionary y equal to, and within curly braces I'll give my key A and I'll assign the value of India. Let's say I have another key B and that has a value, let's say USA. Now if I check A in Y, it gives me true because your key A is present in Y. Now what if I check India in Y? Now this gives me false. So here the membership operator won't work on the values, it only works on keys in a dictionary. Now let me go ahead and change the keys to numbers. I'll give one that has India, and the second key I'll have 2. Now if I change A to 1, it will work fine, it gives me India. But if I write USA in Y, it gives me false. As I said, the membership operator won't work on the values, it only works on the keys in a dictionary. Cool. Now coming to the final section of our demo, we'll explore about bitwise operator. Okay. So Python bitwise AND operator returns 1 if both the bits are 1, otherwise it will return 0. So first let's see 7 ampersand 2. If I run it, it gives me the value of 2. So what Python does is, it will first convert the numbers 7 and 2 to their binary equivalents, that is in the form of zeros and ones, and then it will perform the bitwise AND operation. So 7 ampersand 2, the value is 2. If I write 3 ampersand 5, the value is 1. Again, it will first convert 3 and 5 to binary equivalents in the form of zeros and ones, and then it will perform the AND operation, the bitwise AND operation. Now the Python bitwise OR operator returns 1 if any of the bits is 1. If both the bits are 0, it will return 0. So if I write 10 or 5, it gives me 15. So first it will convert 10 and 5 to binary equivalents, and then it will perform the bitwise OR operation. Let's see another example. I'll write 4 or 8. I'll run it. So the bitwise OR operation gives us 12 as the result. Here we'll focus on if statement and look at a small project in the end. So let's get started. In programming languages, conditions play a very crucial role. They help us develop programs that can satisfy all the business conditions and perform well. So conditional statements are useful when we have to decide that a certain condition or certain part of a code should run only if the condition is true. So the if statement is an example of conditional statements. The program will first evaluate the test condition and will only execute the code block if the test conditional expression is true. So here you can see the syntax of if statement. First we have the if keyword, and inside parenthesis we are going to pass the condition, and if this condition evaluates to true, then we go inside the body of the if statement, which is this part of the syntax. Now, while developing a code for a business problem, you might have to use multiple conditions. So the elif statement is used when we have to check multiple conditions. So here you can see if the first test expression evaluates to false, then you have the elif condition, and if the elif condition evaluates to true, then we go inside the body of the elif statement, which is this part of the statement or the syntax that I'm highlighting. Next, so sometimes you want to evaluate a condition and take one path if it is true, but specify an alternative path if it is not. So this is done with an else clause. So the else code block will run if the expression is false. So here you can see if the condition for the elif statement returns false, then we have the body of the else statement. And finally, after all the if, elif and else statements have been executed, we'll execute if there are any other statements which are present outside the if condition. Now moving ahead, we will use if, else and elif statements to write a program that will solve a business problem. So based on the location and total amount of the items, we are going to find the shipping cost. The locations are a few states in the United States. In the if statement project, we will ask the user to enter the amount of the package or the item, and we'll also ask the user to input the state name. So for the different states, we'll define the conditions using the total amount of the items and print the shipping cost. So let me take you to my Jupyter notebook where we'll do this project. Okay, so I am on my Jupyter notebook. Let me just rename this notebook. I'll say if statement and project. Alright, so let me go ahead and give a comment. I'll say package delivery cost based on the location and total amount. Alright, first and foremost, I'll go ahead and create a variable called total. Now this will be a user input, so I'm using the input function, and here I'll pass the message as enter the amount for the item. Alright, next I'll assign another variable called state. This is also going to be a user input, so I'm using the input function, and I'll say enter the state name in USA. So these are the two inputs we are asking from the user, that is to pass the amount for the item and the state in the USA. Alright, now we'll start with our first if statement. I'll write if state equal to, let's say my first state name is Texas. I'll give a colon. Make sure the syntax you're writing is correct. Now I'm going to use another if statement, so this becomes a nested if statement. Now I'll write if total, which is my item amount, so I'm checking if total amount is less than or equal to 150, then I'm going to print shipping cost in Texas is, let's say, $30. Alright, now I'll pass my next condition using elif statement. Since I'm using multiple conditions, so hence I'm going to use the elif statement. This time I'll write if total is greater than 150 and if my total amount is less than or equal to $250, then I'll say print, I made a spelling mistake, this should be shipping. I'll say print shipping cost in Texas is, let's say, $20. So usually if your amount of the item is high, then the shipping cost is low. So here you can see if the total amount for the package or the item is less than $150, then your shipping cost is $30. But if it is between $150 and $250, your shipping cost is less, which is $20. Then I'll say else print shipping cost in Texas is $5. So what basically this means is, if your total is less than or equal to $150, then the shipping cost would be $30. If your total amount lies between $150 to $250, your shipping cost is $20. And if the cost of the item or the package is more than $250, the cost is $5. So this is for Texas state. Now moving ahead, I'll write elif. This time we'll check the condition for state, let's say Florida. I'll use a colon here and say if my total is less than equal to $150, then we'll print shipping cost in Florida is, let's say, $45. I'll use the elif statement again. I'll say elif total, if it is more than $150 and if it is less than or equal to $250, I'll write print shipping cost in Florida is, let's say, $35. Next, I'll write my else statement. I'll say print shipping cost in Florida is, let's say, $10 if the cost of the item is more than $250. Now one thing to note here is the shipping cost is different for the different states in the US. Alright. Now we'll move on to our next state. Let me give a space here. I'll say elif state equal to, let's say we'll take Virginia now. I'll say if total is less than or equal to $150, we'll print shipping cost in Virginia is, let's say, $23. Alright, I'll just scroll down. Next, I'll write my elif statement. I'll say elif total is greater than $150 and total is less than equal to $250, then we'll print, I just copy this message, paste it here, and we'll say shipping cost in Virginia is $15. Next, we'll write our else statement. Else print, I'll paste the message again. I'll say shipping cost in Virginia is $5 in case the cost for the items is more than $250. Now moving to our final state, I'll write another elif statement. I'll say elif state equal to let's say New Jersey. If total is less than equal to $150, then we'll print, just paste the message here. I'll say shipping cost in New Jersey is, let's say, $40. Now I'll say elif total, if it is greater than $150 and if total is less than equal to $250, we'll print, just put this within double quotes, and I'll say shipping cost in New Jersey is, let's say, $10. I'll say else print my shipping cost is free in case the total amount for the items is more than $250. Alright, finally we'll have our else statement where I'm going to print invalid state name in case the user enters any other state apart from New Jersey, Virginia, Florida and Texas. Alright, so we have our small project ready. Let me just run through it. So first we are declaring two variables, total and state, and we are taking this as user input. So the user is going to input the amount for the item or the amount for the package, and then the user will input the state. So we have the 4 states defined here, and we are checking the shipping cost for these 4 states based on the amount for the items. Alright, now let me go ahead and run it. So here you can see we have our first user input, enter the amount for the item. Let's see, I have my amount as $125, and the next input is enter the state name in USA. I'll say, let's say Florida. If I run this, it gives me the shipping cost in Florida is $45. Let's go to the top and see what we have. Now our total was $125, which is less than $150, and hence it has printed shipping cost in Florida is $45. Let's run this again. This time I'll say, let's say my item costs $255 in the state, let's say New Jersey. Let's run it. You see here it gives us the message shipping cost is free. Now the reason being, if you see this part of the code, for state New Jersey, if the total amount for the items is more than $250, the shipping cost is free. Now let's try for another state. This time we'll see for Virginia. Let's say my amount is $190 and my state is Virginia. If I run it, it gives me the shipping cost in Virginia is $15. Let's check our code. So here I have entered my item amount to be $190, so it lies between $150 and $250, and hence it has printed the message that shipping cost in Virginia is $15. Now let me enter another state name that we have not defined in our code. Let's say I have my item amount as $290 and the state name I'll give is, let's say, Colorado. If I run it, it gives us the message as invalid state, which is present in the last part of our code. So since we haven't defined any shipping cost for Colorado, it has given us the message that the state I am trying to search for is invalid. You can check for another state or any other country name, anything that is not part of our project. Let's say I'll enter my amount as $100, and this time I'll enter my state name as, let's say, Ohio, and we'll run it. It again gives us invalid state. Let's try out one last time. I have my package amount as $350, and let's say my state is Alaska. Again, it says invalid state name because we haven't defined any condition for Alaska state. So this was a very simple project that we did using our if statement. We saw how to write nested if, and we saw how to use the elif and the else statement.
If you're an aspiring machine learning engineer looking for online training and certifications from prestigious universities and in collaboration with leading experts, then search no more. Simplilearn's professional certification program in AI and machine learning from Purdue University, that is in collaboration with IBM, should be your right choice. For more details, you can use the link provided in the description box below.
But today we will focus on for loop in Python and look at different code examples. So what is a for loop in Python? A for loop in Python is used to iterate over the items or elements present in a sequence. The items present in a sequence can be in the form of a list, tuple, dictionary, or even a string. A for loop in Python uses the range function to iterate over a specific number of times. Now let's have a look at the syntax of a for loop. So here on the left you can see the syntax of the for loop. So we have the for keyword followed by the iterator variable. Then we have the in keyword followed by the sequence. It can be a list, you can use the range function, it can be a dictionary, a tuple, anything. And after that you have your colon followed by the statements that you want to execute in the for loop. And below you have the rest of the code. And here on the right you can see this is the flow chart of a for loop. So you have for each item in sequence, then we check the condition. If you have reached the last item, if that is true, you exit out of the loop. But if it is false, you keep on running or executing the statements that are present inside the for loop. This will continue until and unless you have reached the last item in your sequence. Okay. Now let's head over to our Jupyter notebook where we'll see for loop in detail and we'll explore a lot of code examples. Okay, so here I am on my Jupyter notebook. Let's start by writing a simple for loop. Suppose I have a variable, say s, and it has a value which is a string, let's say Simplilearn. Okay, now the way to write a for loop is I'll say for I, which is my iterator variable. It can be any valid variable name in Python, in my variable that is s. So here s becomes my sequence. I'll say print I. So what this for loop is going to do is it will iterate over all the characters that are present in my string and print them one by one. Let me run it by hitting Shift Enter. You see here, using this for loop, we have iterated over all the letters that were present in my string that is Simplilearn, and we have printed them one by one. Okay. Now the print function in Python provides a parameter called end. So by default, the value of the parameter is \n, that is the new line character. Now you can end a print statement with any character or string using this parameter, which is end. Let me show you what I meant. So I'll again have my same string Simplilearn. I'll say for I in my variable or my sequence s. I'll say print I, comma, then I'll use my end parameter equal to, and my end parameter will have a value of asterisk. Now let me run this. You can see here this is sort of a pattern that we have printed. So between each letter in my string Simplilearn we have an asterisk. Okay. Moving ahead, let's see how to use for loop in a list. Alright, I'll declare a list called programming, and this list will contain a few programming languages. Let's say we have Java, and then The next item we have in the list is Python. Next we have Ruby, and then we'll have HTML. Okay, so I'm going to print all the individual items that are present in my list using the for loop. So I'll use the same syntax. I'll write for. This time I'll use my iterator variable name as iter, which means iterator. For iterator or iter in my sequence, which is programming, I'll say print iter. Let's run it. You see here we have printed all the items in my list one by one: Java, Python, Ruby and HTML. Alright, now let's see an example how you can find the average of a list of numbers using for loop. So I'll give a comment saying find the average of a list of numbers. Okay, so here first of all we'll declare a list of numbers with variable list underscore num equal to, it will have a few numbers, let's say 20, 25, 10, 50 and 40. Let's make it 45. Now to find the average of a list of numbers, first I'll declare a variable called sum that will have a value of 0. So we have initialized the sum variable to 0. Then I'll start my for loop for I in my sequence, that is list underscore num, which is this variable. I'll give a colon. I'll write sum equal to sum plus I. So here just give a space to make it more readable. So I'm adding all the numbers in my list and we are storing the result in the variable sum. Then we'll say print sum equal to, I'll pass in my variable that is sum. Then I'll say print average equal to, now our average will be my variable sum divided by the length of my list that has all the numbers. Let's run this. You see here, so our total sum of all the numbers present inside the list is 150 and the average of all these numbers is 30. So 150 divided by 5 is 30. Alright. Now let's see how you can use a for loop using a tuple. So let's declare a variable called num. This is going to be a tuple of numbers and we have 30, 45, 60, 50 and let's say 70 as the numbers inside the tuple. I'll say sum equal to 0. Then we'll have our for loop for I in my sequence, that is num. I'll say sum equal to sum plus I. So here we are just adding the values that are present inside the tuple. I'll say print sum. So here you can see we have printed all the values present inside the tuple one below the other. Now if I shift my print statement to here, you can see here this is my sum of all the numbers that are present inside the tuple. So make sure you have the current indentation. Now let's see how you can use the range function in Python. Okay, so you can use the range function to iterate over a range of values or numbers using a for loop. The way to do is I'll say for I in my function range, I'll give my first index at 1 and my second index at, or my end index at 10. So this will go from 1 till 9 and exclude the 10th index. I'll say print I. You see here, for I equal to range 1 to 10, we have printed all the numbers starting from 1 till 9. So the last index, that is 10, is exclusive in the range function. Now in the range function, you can also give a third parameter that stands for step, so that you can skip a few steps and print the next value. Let me show you what I mean. Say I write for I in range 0, which is my starting index, 10, which is my end index, and I'll have a step size of 2. Give a colon. I'll say print display values with a step size of 2. Give a comma here and my variable, that is I. Let's print it. There you go. So we have printed the values with a gap of 2. So it starts from 0, then we are jumping 2 steps, and then we are printing 2, then again 2 steps, we have 4, 6 and 8. So we are skipping one value and printing the next value in my sequence ranging from 0 to 10. Alright, now let's write a program to print a table of a given number. So I'll give a comment as program to print table of a given number. Alright, so I'll pass my variable n, which is going to be a user input. So I'm using the int function, and inside the int function I'll use the input function to take the user input. I'll give my message as enter the number. I'll say for I in range from 1 till 11, I'll say multiply, which is mul here, n asterisk I. So basically what I'm doing here is I'll take a user input of the number. Let's say we want to print the table of 5. So from 1 till 10 will have the product of the numbers. Let me print it. I'll say print n comma within double quotes I'll give my asterisk comma I comma within double quotes I'll say equal to, and then we'll have our variable mul. Let's run this. Enter the number. I'll give 5 and hit enter. There you go. So here we have the multiplication table of my number 5. So you say 5 into 1, which is 5, 5 into 2 is 10, then we have 5 into 7 35, 5 into 9 is 45, then our last index which ends at 10, so we have 5 into 10, that is 50. Alright, so this is how you can create a simple multiplication table using for loop in Python. Now we can also use the range function with a sequence of items. The len function can be combined with the range function to iterate through a sequence using indexing. I'll show you an example here. Let's say we have a list called list2, and here we have a list of programming languages, let's say C++. You can either use a single quote or a double quote to represent the text values in a list. The next programming language I have is Java. Then let's say I have Python, and we have R. Okay, so I can write for I in range. Here I can use the length function, and I'll say list2, give a colon, then we'll print hello, and I'll say list 2 of I. So what it does is my iterator will iterate over the list of programming languages I have here, and it will keep on iterating till the length of the list. And then I'm printing my message as hello, and it will take each item from the list using the index number. If I run it, you can see here it says hello C++, hello Java, hello Python, and hello R. Cool. Now let's see how you can use nested for loops in Python. I'll say nested for loop as my comment. Let's say I have a list of company names. My first company I have in my list is Google. Let's say Apple, PwC, and then we have Uber. So here I'll write for I in companies, I'll say print, we will display each letter of, I'll say plus I. Now I'll use my second for loop saying for letter in I will print the letter. Let's run it and see our result. There you go. So here we have used two for loops, so that becomes a nested for loop. We have my outer for loop and then we have our inner for loop. So in the outer for loop we are just printing the name of the company. So here we say we will display each letter of plus I, which stands for my company name Google. So you can see below we have displayed each letter of Google using the inner for loop. Similarly, we have for Apple, you can see APPLE, we have PWC, and then we have Uber. So this is how you can use multiple for loops in Python. Now let's see how you can use a for loop with else clause. So I'll give a comment for loop with else clause. So I'll write for I in range 0, 10, I'll give a step size of 3. I'll say print I, and after this Python gives you the flexibility to use an else clause after the for loop. So I'll write else print the loop has completed execution. So this is my message that we are going to print after we have printed all the elements that are present inside this range function. Let's run it. You can see here we have printed the value starting from 0 with a step size of 3. So we have 0, 3, 6 until 9, and then after that we have our else block printed, which has the message the loop has completed execution. Cool. Now let me show you two more important features that you can use while writing a for loop. One is called the break statement, the other one is called the continue statement. So in Python you can break the for loop and end it before it has actually run all the elements in the iterable using the break statement. So let me show you a simple example. If I write for, just give a space here, I in range, let's say from 1 to 10, I'll use an if condition saying if I equal to 6, then break and come out of the loop. Next we'll print I. So here what we are doing essentially is we are iterating over all the values from 1 to 10, and whenever the I value becomes 6, we come out of the loop and print all the values we have iterated so far. Let me run it and we'll see the result. There you go. So here our I value started from 1. We printed 1, 2, 3, 4, 5, and then our I value reached 6. Then we use the break statement to come out of the loop. Alright. Now you can also skip the execution of further statements in the for loop during that iteration using the continue statement in Python. So when a continue statement is executed, the for loop continues with the execution of the next element in the iterable. It does not complete all the statements in the for loop body. So again, I'll give a comment, say continue. Okay, so I'll write for I in range, again from 1 to 10, give a colon. I'll say if my I value is equal to 6, then I'll say continue. Then we'll print I. Let me run it and we'll see the result. Okay, so if you notice this output, so we have printed values from 1 to 5, and when my I value became 6, we skipped printing 6 and we moved on to the next element in the iterable, which was 7. Then we printed 8 and 9. So this is how you can use the break and continue statements in Python. Alright. Now we'll see a program to display the total goals a player has scored. So here we are going to iterate over a dictionary. So I'll give a comment, program to display the total goals a player has scored. Alright. So first of all, I'll declare a variable saying player name, and let's say we have the player name as Carmelo. Alright. I'll declare a dictionary called goals, and within curly braces I'll have my first player name addition. Let's say addition has scored 14 goals. Then we have, let's say, Burnett. So Burnett is my key here, and then we'll have value in terms of goals, let's say 3, and then we have our third player, let's say Carmelo, and Carmelo has scored, let's say, 7 goals. Now I'm going to write my for loop. So I'll write for my iterable name here is player, in my sequence name is goals, so I'll say goals. I'm going to check if my player is equal to player name. I'll say print the goals scored by the player. So I'll pass my dictionary name, and within square brackets I'll say player. Let's use the break statement, and then I'll say else will print, my message would be no player with that name found. Let's run and see the result. Alright, so here what we did was, initially I declared a variable called player name that had the value Carmelo, and since Carmelo was present inside my dictionary named goals, you can see here we have Carmelo who had scored 7 goals. So I iterated over my sequence goals and I checked if my iterator, that is player, is equal to the player name, which is Carmelo. Since this Carmelo is present inside my dictionary name, so we printed the goals that were scored by Carmelo, that is 7. Now let's say I change this player name to, we have, let's say, Messi. Now since Messi is not present inside my dictionary goals, if I run this, it will print no player with that name found. The reason being message not present inside my dictionary called goals. Cool. Now we'll see two more examples. This time we are going to print the cube of numbers using for loop. Alright, so first of all I'll declare a list which will have a list of numbers, let's say 2, 5, 7, 4, 8 and let's say 6. Then I'll pass in a empty list, so I'll declare within empty square brackets. I'll say for I in my sequence name, that is num, I'm going to use my empty list cube and then followed by the append function, and inside the append function we'll have our cubes of the number. So I'll write I'll use the double asterisk operator and then I'll say 3. After that we are going to print my list name, that is cube. Let's run it. There you go. So you can see here, first we have the list of the numbers here, and then we have printed the cubes of these numbers in a pattern. Let's say I bring this print statement here and I'll run it again. Now this is much more readable. You have 2 cube is 8, 5 cube is 125, 7 cube is 343, then 4 cube is 64, 8 cube is 512, 6 cube is 216. Alright, now coming to the last example in our demo section of this for loops in Python video, we'll write a program to print a pattern. I'll say pattern printing. Alright, so we are going to print a right angle triangle. For that I'm going to take my first variable called n, which is going to be a user input to enter the number of rows. So using the input function I am passing the message enter the number of rows. I'll say for I in range 0 till my user input n, give a colon. I'll use my inner for loop. This is going to be the number of columns, so I'll say for j in range 0 comma I plus 1, give a colon, and I'll print my star pattern, so I'm using asterisks, and I'll use my end parameter. I'll have my double quotations and then we'll say print the pattern. So here what I'm doing is I'm taking the number of rows from the user and I'm iterating from 0 till n, which is my user input, and then we are assigning another for loop for the number of rows, so that ranges from 0 till I plus 1. Then I'm printing my star. Let's run it and see the output. Let's say I'll enter the number of rows as 6. If I hit enter, you can see here we have our right angle triangle printed here. So initially my I value is 0, so here my j value becomes from 0 till 1, so we have just one star printed. In the next iteration my I value becomes 1, so from 0 to 1 plus 1, that is 2, we have 2 stars printed. The next iteration, my I value becomes 2, so 2 plus 1 is 3 again. So we have 3 columns here, so 3 stars printed, so on and so forth. We will learn 3 hands-on projects that will help you improve your Python coding skills. We have with us Anish Karan, who will take us through these projects. So the first project we are going to see is, given a block of text, you will count the frequency of each word occurring in the text or paragraph. In the second project, you will trace the movement of a robot. The robot can move up, down, left or right. You will write a program to find the distance between the starting point after a sequence of movements. In the final project, we will write a program to check the validity of passwords given by the user. Often, while logging into a website or an application, you are asked to input the username and password to register. Our project will check the criteria for setting a password and approve it only when the criteria are met. So a password should have at least one letter between A to Z, at least one number between 0 to 9, one uppercase letter, one special character, and so on. So let's get started with our first project.
Hello everyone and welcome to another video on Python programming. In this video we will be covering a sort of a project type of scenario, which is basically going to be a problem case for you, and it's going to be slightly difficult, slightly tricky, but what we're going to do is we're going to tackle a particular problem, and we're going to what I'm going to do is also show you a solution to that problem. So let's start with this. So this question that we have is, we have this program that we have to write where we compute the frequency of words that exist in some input. Okay, the program should output after sorting the key alphanumerically. Now this input can be it's basically a block of text, right? So in our example we have, for example, if this was our input, right, what we want to see is an output which is basically saying that the word Python has appeared, say, well, in this example it's appeared 5 times, and then the word read has appeared 1 time, and so on and so forth. Like for each of these words we want to see how many times have they appeared in this particular block of text. So let's look at a particular example now where we have done this. So let's see here. So first of all, I'm going to create a dictionary. So why am I creating a dictionary is because I'm going to use each unique word as a key and the number of times they have appeared in a block of text as the value to that key. So I'm going to use a sample string, which is basically this long string that you can see here, which is stored in line. So this large chunk of text is what we're going to be analyzing. So how are we going to do this? It's pretty simple. So we have this. Now what we want to do is, when we find one way of tackling this problem that we're going to do here is we want to check word by word. First of all, we want to see if it's a unique word, and if this word is before I encountered it for the first time, then we need to store a new key in our dictionary called frequent table or frequency table. And if it has already, if there is a key already with that particular name, then we just want to increment the count or the value by 1. So let's see how we do this over here. So if you can see in the solution is as simple as this, but if you see what's happening, it's basically what it's doing is we're splitting up this string using the split function. What this will do is it will split up the string at every white space. So it will take this as one part, it'll take this part as another part. It will create an iterable with each word as the each iterable object in that container. So it's going to be a list of words like Python is 1, so on and so forth, and we're going to go one by one. So we're going to say for word in line.split. Now if this word if it exists in frequency table as a key, then what we're going to do is we're just going to increase the count of the value of that key by 1. But if it does not exist, then we're going to actually create a key with the word as that unique word, and we're going to create its value, initialize its value to 1. So when we execute this, now if we want to, once we've done this, we can sort it by the count of the words. So what we're going to do is we're going to create another tuple called sorted tuples, where we're going to use the lambda function out here to sort the dictionary in terms of its values. So what we're going to do is we're going to take the key being the lambda item with index 1. Index 1 is basically the value. So a particular key has a value. So the word Python appears so many times. The word say scientist appears so many times. So we're going to check which words have the highest number of occurrences, and we're going to sort it in a descending order. So that is basically what the reverse is equal to true does. So when we're going to sort this, when we're going to use the sorted function, when we say reverse true, it tells the sorting function to sort this dictionary frequency table in terms of value by the descending order. So whichever word appears highest, that will be the first word in our sorted tuple. So that's what we do in this line, and once we execute this, we're also going to print. So if you see the result of this activity that we've done, you can see that the word machine appears 6 times, learning appears 6 times, then Python appears 5 times, and so on and so forth. So we've created a sorted tuple where the first object of the tuple, we've created a list of sorted tuples where the first object of each tuple is the unique word, and the second one is the number of times that it has appeared in this particular example or this particular string. So yeah, this was the first basic project that we have tackled.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Hello everyone, and welcome to another video on Python programming. In this video, we will continue with what we started in terms of our project number 1. What we're going to do is we're going to tackle another slightly complicated question or a situation. We're going to try to arrive at a solution. So in this, what we have is some sort of a robot, a moving robot, which moves on a Cartesian plane, a 2-coordinate plane, is going to move in terms of up, down, left, and right. Okay, and each time it moves up or down or left or right, it takes a certain number of steps in that direction. Integral steps, of course. So what we need to do is from its starting position, whatever its starting position is, which we're going to take as 0, 0 in this example, we're going to make it move to a particular location with the commands up, down, left, and right, followed by certain steps. And we're going to what we're going to do is we're going to calculate the distance between these 2 points. And we're going to calculate different types of distances. So you might be introduced to new concepts, new distance concepts in this video as well. So what we're going to be using for distance calculation is the Minkowski distance. And that is, we're going to take, so the Minkowski distance between 2 variables is basically the absolute difference between these 2 variables, so these 2 points, and we take it to the power of something. So if we want to say calculate the Minkowski distance with in terms the quadratic Minkowski distance with basically p2, so we are going to do xi minus yi, absolute difference to the power 2, and then we're going to take the second root of it after summing each and every point. So when we take p is equal to 2, we say the Minkowski distance behaves like the Euclidean distance, and this is probably one of the most common distances in case you've done basic Cartesian geometry. When you're asked to find the distance between 2 points on a plane, we can also take the absolute distance where we take p is equal to 1. So in this case, we're just basically summing the absolute distances between each point. No roots, no powers, nothing. Basically p is equal to 1, and we call that the Manhattan distance. So we're going to take p is equal to 1, 2, and 3 in each case, and we're going to find the distance between 2 points based on these measures. So this is just a visual representation. This is basically the Euclidean distance, is basically the estimate of the value between these 2 points. If since this is a 2-coordinate system, whereas the Manhattan distance would be the absolute distance in terms of if we go up and then we go right between these 2, like say if this was and this was another point. So yeah, let's move on to the problem. So what we're in this particular example, we're going to start from the starting position 0 and 0 on a graph, and we are going to give the commands of up 5, down 3, left 3, and right 2. So first of all, what we want to do is we initialize the starting position as 0 and 0, and we also, just for the sake of this example, we initialize the end position as 0 and 0. So what we're going to do first of all is, let's execute this much. Now we have this list of tuples. We're going to call this actions, and this is the actions that we're performing. So each tuple contains an action and the number of steps in that direction. So it contains 4 actions: up by 5 steps, down by 3 steps, left by 3 steps, right by 2 steps. So now we're going to iterate over this each tuple, and we're going to get the direction first of all in this line for each step, and we're going to calculate the number of steps it takes. So for each action, it's going to first tell, it's going to check what is the direction which is done by this line, and we're going to find out the number of steps in that direction which is stored in this line. So once you've gotten this, for each action we have to update the end position, right? So what happens is, if you go up by a particular direction, so you are basically changing the y-axis, right? The y-axis. So we're going to change end position and the first index, which is basically this part of the end position coordinate point. So we're going to say if it's moving by up, then we're going to update by adding the y-axis by the number of steps. So and if the direction was down, we're going to do the same thing for the y-axis, but we're going to decrement it. Similarly, if we move left or right, we're moving the x-axis, right? So we take end position and the first index. So we take the x-axis, and if we're moving left, it's a negative, it's a decrement, and if you're moving right, it's an increment. So if there's any other action, like any other action, for example, that was given here, we say pass. So basically the only valid actions that we can pass is up, down, left, and right. Otherwise we just skip that particular action. So this is what this particular loop will do. It will update our final position. So once we've done this, if I execute this, what will get stored in the end position is basically my end position. So now that I have my starting position and my end position, just to show you what the end position will look like right now, let's just do this. So if you see here, after I've moved up by 5 steps, down by 3 steps, left by 3 steps, and then right by 2 steps, my final end position is -1 and 2. My start position, on the other hand, was, as you remember, it should be 0 and 0. It is 0 and 0. So now we're going to find the distance between 0 and 0 and -1 and 2. So we're going to first of all create a function called Minkowski distance, which does a basic function of just calculate the difference between the the end position x coordinate and the end position y coordinate times or to the power of a root. And we're basically going to do this operation that you saw here. We're going to do this, and we're going to use this root variable to specify to p is equal to 1, 2, or 3, like what p value we want to take for this Minkowski distance. So once we've done this, what this function will do is basically store this much, and it will wait for us to give us a root. So when we give root 1, it will create these, it will check the distance between the end and the starting points with the p-value of 1. If we gave it 2, it will calculate Euclidean distance with p-value 2. Similarly for 3, and we can calculate for any roots. So we're going to calculate for 1, 2, and 3 roots, and we're going to see what values we get in each case. So when root is equal to 1, I print a statement saying Minkowski distance with root 1 is something, and then root 2 is something, root 3 is something. Let's see what results we get. So if you see here, the Minkowski distance with root 1 is actually 1.0, but the Euclidean distance between these 2 points is 2.23, whereas the cubic Minkowski distance with root 3 is 1.91. So you see these 3 different distance measures for the same distance between 2 points. So in this video, by doing this activity, you will learn how to how to iterate through loops and perform these distance calculations, which you'll find pretty handy in many activities related to data science and machine learning. So yeah, this was on the project 2. Hello everyone and welcome to another video on Python programming. In this video we will be continuing tackling different problems and problem cases in terms of a project called Project 3, where we're going to be using regular expressions to validate whether certain passwords that have been entered, do they match certain criteria or not. So let's look into our particular question. We have a website that requires users to input username and password to register. Now we have to write a program to check the validity of passwords input by the users. Now the criteria that the passwords have to follow are that there's at least one number between A and Z, and there's at least one letter between A and Z and one number between 0 and 9. The third criteria is that there's at least one letter between capital A and capital Z. So this first and third point basically is saying that there should be one lowercase letter and there should be one uppercase letter. Now there should be at least one character from $, hash, or the @ symbol. It should have a minimum length of 6 and the maximum length of 12. So when whatever passwords that we enter into our example, they must be comma separated. So if we're going to have an input, they're going to ask us for an input where we're going to have to input the different passwords in a comma separated way. So let's look at how do we tackle this. So for my example, I'm going to use these examples in terms of these are my password examples. If we're going to check if these are valid passwords or not. So let's copy this first of all. And now let's import the RE. RE is basically the regular expression module. Now in this step is going to ask us to input the passwords, as you can see here. So I will just Control V. So since this is comma separated, what it will do is it will split up each of these by the comma and it will store them in a list. So it will take this as one password, this has another password, this has another password, and this has another password. Once I press enter, now if I want to check what's in list, what's in items, what I can do is just check over here what's in items. It's a list of whatever passwords I had entered. Each object is separately treated now in this list. Now I'm going to create an empty list called value first of all. Once I've done that, I'm going to move on to the next step. So once I've created my list called value, what I'm going to do is now I'm going to search and I'm going to check for each condition using regular expressions for whatever criteria that we have initially. So if you see here, what I'm going to do is first iterate by each item in this to check for each password. Now my first check will be a basic check for the length of the password. If it's lesser than 6 or greater than 12, then our password is illegal, so we can't be using this and we will just continue and we won't check for anything else. But if it is within 6 and 12, the length 6 and 12, then we can continue with our check. So we'll do an else statement for pass, which basically moves on to this next block. Now once we've done this, what we will do is this first statement, what this is going to do is going to do an re.search. And re.search, as you know, is going to look for at least one instance of a letter occurring between A and Z. So this re.search followed by this. Now this is the regular expression that we have passed, and what this tells us is basically the square brackets, we're looking for anything between A and Z in terms of small letters. So if this condition is not met, then again we continue and we leave this particular search because one of our criteria is not met. Alright, but if it is met, then this if not statement will not we won't enter this block and we can move on to the next check. So now we move to elif not. Now again we're using if not statement. So this is basically checking for a negative case. So anytime one of these cases have been met, it basically means that our password has been invalid because these conditions are not being met. So we're trying to eliminate all conditions, all of these conditions, so that we get a valid password. So again we move on to the next statement, which is basically going to do the search for numbers. Once again, if we find a case, a password without any numbers, we continue and we don't check this password no more because we already know it's an illegal password. Now next check will be for capital letters A to Z, and the next check again will be for these particular symbols, the $, the hash, and the @ one of these three symbols. Finally, we have a search for we're going to search for a white space character. So if we actually do find a white space character in our password, that's an illegal password, and we're not going to continue checking for those cases. So so this is basically all our cases: lowercase letters, numbers, capital letters, one of these three symbols, and the existence of a white space. So once we've done all these checks, if none of these have been passed, we move on to this else statement where we just pass. And what we can do is we append the value. We append the value to we append p to the list called value. So basically, what happens is, just to go through it again, if this condition is not met, and this condition is not met, this is not met, this is not met, this is not met, and if this is also not met, then we're fine. So basically, as long as we have small letters, as long as we have a number, as long as we have a capital letter, as long as we have one of these three symbols, and as long as we don't have any white space characters, we can append p to this. Otherwise, it will continue and it will break out of this for loop completely. That's what the continue statement at the end of each of these blocks checks. Anytime this condition is met, this if not condition is met, then we break through this whole for loop, and we don't append p to the value. But if we actually get to this stage, then what we can do is simply append p to value. Now, finally, what we are going to do is we're going to print out all the valid passwords. So just by a quick look, you can see here, this is a valid password, right? So let's execute this and let's see what we get. If you see here, we only get one valid password, and let's look at why some of these did not turn out to be valid. So if you look here, all of the conditions are met. It has a capital letter, it has a small letter, it has at least one number, and it has one of the symbols, either $sign or the hash sign or the @ sign. In this case, we have two white spaces, one over here and one over here. So this is an illegal password. Similarly, in this case also we have an illegal password because it begins with a space. In this case, it's the same thing. We begin with a space, and also it does not have any of those symbols that we were looking for, the $ or the hash or the @. So again, so these three are illegal passwords and they do not get appended to value. However, this does get appended to value, and that's why we get the result for only one password, which is the only legal password.
And this was all for this Python basics. Hope you guys found it informative and helpful. If you like this session, then like, share and subscribe. If you have any questions, then you can drop them in the comment section below. Thanks for watching, and stay tuned for more from Simplilearn.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.